Good morning, ladies and gentlemen. It is with great pleasure and honor that I introduce our distinguished chief guest, Honorable Chief Minister, Housing and Urban Affairs, Petroleum and Natural Gas, Shri Hardeep Singh Puri ji. We are also privileged to have amongst us the Ambassador of Norway, Her Excellency May Ellen Stenner, Secretary, Housing and Urban Affairs, Shri Manoj Joshi ji, the Director General, CPWD, Shri Rajesh Kumar Kaushal ji, and the Chief Scientist, Dr. Christian J. Engelsen. I welcome you all, sir, and ma'am. I, on behalf of CPWD and CINTEF, extend a very warm welcome to you all, and thank you for your presence. As I look upon all of you, I'm reminded of the rich cultural traditions that bind us together, one of them being lighting the lamp, which holds profound symbolism, signifying the dispelling of darkness and the ushering in of light, knowledge, and prosperity. It is a tradition that resonates deeply with our collective ethos, reflecting our reverence for wisdom, enlightenment, and the auspiciousness of the new beginnings. To shubh kaam mein deri kaisi. To honor the said tradition, we humbly request Honorable Minister Sir Shri Hardeep Singh Puri ji and other dignitaries to please light the lamp to fulfill the sacred ritual and commence the workshop. Can I have a round of applause, please? Thank you for your blessings. Esteemed guests and our effervescent audience, my name is Ravneet Guleria, and it gives me immense pleasure to extend a very warm welcome on behalf of CPWD, Central Public Works Department, and CINTEF. We are privileged to have you join us for this workshop on recent development with recycling and use of construction and demolition waste. Today marks a significant moment as we come together to explore new ideas, share expertise, collaborate on solutions, etc. It's not just a workshop, it's an opportunity for us to engage, learn, and grow together. Construction and demolition. Waste arises from infrastructure construction and demolition activities. India's construction industry is projected to reach $1.4 trillion by 2025, contributing 13% to the national economy. This growth will result in significant waste generation and increased demand for natural building materials. Mismanagement of C&D waste, often improperly disposed of in sensitive areas, causes environmental harm. Additionally, construction activities themselves generate dust and particles, further contributing to pollution. As we embark on this journey together, let us keep an open mind, embrace diversity of thought, and foster an environment of respect and collaboration. In response to these challenges, effort towards the reuse of recycling and C&D waste have gained momentum in India. The journey began with the signing of an MOU between CINTEF and CPWD in 2016, approved by the Union Cabinet. CINTEF, a renowned R&D organization from Norway, specializes in C&D waste management, studies, and recycling technologies. This workshop, organized by CPWD in collaboration with CINTEF Norway, aims to explore the latest developments in C&D waste recycling, sharing experiences, discuss challenges in utilization, examine the economics of recycling, and promote best practices in the field. As Lucy Larcombe said, "He who plants a tree plants a hope." Bearing this thought in mind, and as a gesture of gratitude For your invaluable contribution and encouragement, we present you with a sapling. May it serve as a reminder of the seeds of change we plant today for a better tomorrow. May I please request the Director General, Shri Rajesh Kaushalji, to please felicitate the Honorable Minister, Shri Hardeep Singh Puri ji. Can we please have a round of applause? Requesting Director General Rajesh Kumar Kaushalji to please felicitate Her Excellency May Ellen Stenner, please. Could we please have Director General Rajesh CPWD to please, Rajesh Kaushalji CPWD to please honor the Secretary Housing and Urban Affairs. Inviting Additional Director General Sir Naemuddin to please felicitate Director General Rajesh Kumar ji. May we have the pleasure to have Additional Director General Shri Naemuddin Sir to please honor Dr. Krishnan Engelson. Thank you, sir. To further the program, may I please call upon Shri Rajesh Kumar Kaushalji, Director General CPWD, to say a few words.
Honorable Minister of Housing and Urban Affairs, Shri Hardeep Singh Puri ji, Her Excellency May Ellen Stenner, Ambassador of Norway, Respected Secretary, Ministry of Housing and Urban Affairs, Shri Manoj Joshi ji, Dr. Krishnan, Chief Scientist, CENTAF, guests, senior officers of CPWD, colleagues and friends. It is a matter of immense pleasure and to joy partner with CENTAF for organizing this workshop meant for spreading awareness, discussing the new technologies, development, sharing cases, studies, and their implementation of C&D waste management in the construction sector. CPWD and CENTAF are associated in the area of C&D waste management since 2015 as a part of Indo-Norwegian C&D waste program and formally signed MOU in the year 2016 after approval of Union Cabinet. Since then, we are jointly work to develop the use of recycled C&D waste products and capacity building of our officers in this area. The two batches of CPWD officers sent to Norway for kind study tours. This MOU is an under consideration of renewal for further collaboration in this area to continue the capacity building of CPWD officers and further development in the use of recycled C&D waste. The C&D waste management has part of this initiative of Honorable Prime Minister Swachh Bharat Mission 2.0, in which all states are to participate in the production of reusable products at C&D waste plants. Recycling and reuse of C&D waste is instrumental in the circular economy of waste management as envisaged in the vision of Honorable Prime Minister in Swachh Bharat Mission. The vision of Honorable Prime Minister to create clean and garbage-free India is being achieved through Swachh Bharat Mission 2.0. To ensure cities becomes garbage-free cities, GFC, by 31st March 2006 can be done only through 100% scientific and solid waste management in the construction sector, efficient construction, management practices, minimize waste and dust emissions, and putting in place extensive awareness, capacity building, and enforcement measures will help cities to achieve the target. It gives me immense pride to highlight the fact that CPWD has been one of the front-runner in the recycling, reuse, and management of construction and demolition waste in the country. CPWD had included C&D recycled materials, namely precast, solid cement concrete blocks, and paper blocks in DSR 2016, and recycled aggregates and recycled concrete aggregates in DSR 2018. The DSR items are used by many central state government departments and public sector undertaking for making building across India. Besides that, CPWD has issued various advisories for compliance of construction and demolition waste management rule 2016 in its projects. CPWD has been integral part of forming the guidelines on environmental management of construction and demolition C&D waste issued by CPCB in 2017. CPWD mandated proper recycling and reuse of C&D waste and products in its projects since 2017. BIS, the Bureau of Indian Standards, IRC, Indian Road Congress, have been made responsible for preparation of codes of practices and standard for use of recycled material and products of construction and demolition waste in respect of construction activity. CPWD was actively involved in the formation of codes related to C&D waste products. Various advisories for the same were issued in 2017-18 in this purpose. As per the guidance and the direction of Ministry of Housing and Urban Affairs, CPWD mandated use of 10 to 20% recycled materials and products in all its projects in NCT of Delhi since 2018. The C&D waste blocks as a non-structural member was mandated to be used in building having height less than 15 meter in place of clay bricks in Delhi, NCR, Mumbai, Chennai, Kolkata, Bangalore, Hyderabad, Ahmedabad, and Surat. CPWD has been already used more than 1 lakh metric ton of C&D waste generated processing plants for the year 23-24. CPWD has used around more than 40,000 cubic meter of recycled products in its projects since 2024. It's focusing on the use of recycled waste products to extent possible so as to achieve the objective of zero waste from its construction sites. In CPWD contracts, stipulation have been made for handing over of C&D waste generated from demolition of building to C&D waste processing plants for recycling. Currently, we are using C&D waste material in our projects in shape of bricks, PCC blocks, paper blocks, curbstone, cement concrete tiles. In Delhi, so far, 6,800 metric ton of C&D waste material have already been utilized by us. This has resulted in saving of equal quantity of natural stone, sand, and reduction in CO2 emission by over 137 metric ton, and saving in water of is more than 5,400 kiloliters. This is just a beginning, and much more needs to be done in this area. To continue the process in this area and promote knowledge sharing, the area this workshop has been organized in collaboration with SINTEF. The various technical presentation beginning with legal provision in the current C&D waste management rules, experiences, sharing, recycling by the speakers from CPCB and Goa Waste Management Corporation will be highly informative and used for all stakeholders. Present in this workshop, recent advances in the field economy model present for C&D waste recycling, challenges for implementation of recycled material in large-scale projects, and their use. CPWD projects are also some of the issues that would be taken up in this workshop. I hope this workshop will enlighten various stakeholders for better practices on the subject so that we can have more holistic sustainable development. With this, I conclude. Thank you. Jai Hind.
Thank you, sir. Exploring our future means exploring science. And who better to share that knowledge with us than Dr. Krishnan Engelson? Kindly join me in welcoming him and with a warm round of applause.
Honorable Minister, respected dignitaries on the dais, ladies and gentlemen, I'm very honored to have the introduction address. Construction and demolition waste is very important to recycle. Why is it actually so important? It is actually consisting of large volumes of materials that can be recycled, and it's considered as an enormous resource for the construction industry. If you go to the global consumption of concrete, we are saying that almost or around 1 Mount Everest mountain is consumed every year. And concrete is consisting of water, stone, and sand, and cement. So these materials are causing enormous outtake of raw materials. That's why we are focusing so much together with CPWD to recycle this solid waste stream. We have had many full-scale pilots since the late 1990s, and also full-scale pilots together with Indian partners. That's why we provided this background in 2016 and went into a collaboration with Central Public Works Department and also premium construction contractors like Godrej and L&T, and also with expert institutions like Recycle Triangle Institute and Resilient Energy. Also, we have made a MOU with the Goa Waste Management Corporation. So altogether, it makes an excellent collaboration team to continue to increase the treatment and recycling of C&D waste. We have had an excellent, over the years, collaboration with CPWD and conducted awareness. We have conducted study tours and also done technical pilots together, also with relevant industry and recycling operators, which are actually present in this room today. So, all in all, this has resulted in quite many or quite relevant documentation, which is actually being available for all stakeholders, which we see as a very important initiative. We will have more of these recent advances later today, and I hope that everybody will join in technical session 1 and technical session 2 in order to have to receive the messages on how we are doing the sustainable circular concrete materials for by recycling construction and demolition waste in a very high level. Thank you very much.
Thank you, sir. I'd like to now welcome Shri Manoj Joshi ji, Secretary Housing and Urban Affairs, to share with us a few words of wisdom.
Honorable Minister and dignitaries on the dais, there are two sides to construction and demolition waste. One is the collection and one is the utilization. In Swachh Bharat Mission, we have been dealing with this issue on collection side. And if you go around cities in India, you would find on the roadside contractors dump construction waste. And it is outside the city limits, where the habitation is not there. Both the sides of the roads, you find a lot of construction waste, debris being there. At the same time, all these legacy dump sites, including in Delhi and Mumbai, when you remove the legacy waste, almost half of it comes as a inert material. That is primarily nowadays used for national highway or road construction as a earth filling material. NHAI has been quite willing to utilize those inert materials, though a lot of times the cost of transportation, depending upon where the road construction is happening, determines the cost which is required for that purpose. And under Swachh Bharat mission, we have set up C&D plants across the country in the cities. Delhi one is functioning most in a best way. The rest of the plants, they have a supply problem. I think that a typical contractor attitude who is undertaking demolition is that where is the least distance they can incur for taking the demolition waste. If they find that there are parts of the city or water bodies or highway which are closer to reach rather than a C&D collection point, they would do that because of slightly lack of regulation on that part and people dumping their waste. Wherever, I think that's why a lot of collection centers have been opened in some cities. So the more collection centers are there by municipal corporation, contractor finds it cheaper to go and dump it in demolition waste if going to outside city is longer. So I think that as a strategy of opening a lot of collection centers is improving collection of C&D waste, but still it's quite a challenge, particularly from the demand side. As DG CPWD was saying, we have prescribed a lot of guidelines, but there is no force on the contractor to use them unless they find it more profitable or less cost to use recycled material based bricks. So fly ash bricks, they are using it because they are cheaper. Demolition waste made bricks or blocks, the utilization is far less. Utilization is far more in the pavements, the debris to be utilized in the pavements, similarly in the road construction. But in a country like India, where such a large construction is happening across the country, and we would keep doing it for next 20, 30, 40 years. And there is a limitation on how much sand we can extract from the rivers, how much stone we can take it out of the hills. So the more and more environmental restrictions are coming up, and more illegal extraction of stone and sand is happening because there is a large demand, and we have, because of environmental restrictions, we have put regulation on legal extraction of these materials. So the only source of legal restriction in C&D waste, and which contractors are not that inclined. So one is we need to make it profitable for contractor, or by regulation that they must use it. So a lot of cities have issued regulations, but they're not enforcing it. So one is the technical aspect of better utilization of construction or demolition waste into building products and making them of good quality. I'm sure Sintef and CPWD has done some more work on that. But I think probably better work needs to go with the agencies which are making that those building products, whether it's a tiles or whether it's a bricks. But also the entire management of demolition waste is a very complex issue. We need to make it profitable for every handler of that waste to do it in a particular way. As of now, we have done bits and pieces, but we need to put all those bits and pieces together, at least so that the entire value chain works. In legacy dump site, that value chain is working because there is a contractor whose job is to take out that legacy waste and use that inert. So that site is working. In terms of demolition waste and C&D collection centers, reprocessing and utilization again by the contractors, that chain is not complete. That's why Along with the discussion on technical aspect, we need to discuss how to build the entire economic chain so that it's profitable and the chain gets completed. I hope today's deliberations would work further in that direction. Thank you.
Thank you, sir. I take immense pleasure in now inviting Her Excellency the Ambassador of Norway, Ms. May Ellen Stenner, to share the experiences and learnings with us.
Thank you so much. Dear Minister, very happy to share the dais with you. Secretary Manoj Joshi and Director General of CPWD and colleagues from SINTEF and everyone in the room. It's such a pleasure to attend this workshop on recycling and use of construction and demolition waste. It's a very important topic. All of us are adding new or refurbishing old infrastructure every single day. Even more true of India, where investments are surging in the transport, electricity, housing, and industrial sectors. I must congratulate you, Minister Puri, and also your government and Prime Minister Modi for launching several mega projects such as the smart cities, heritage city development, PM Awas Yojana, and many other ambitious infrastructure development initiatives. The Indian construction market size was 700 billion in 2022 and is projected to achieve an average annual growth rate of more than 5% during 24 to 27. Growing construction activities also means a lot of waste is generated. Its scientific management, therefore, is important. Successful recycling is both economically and environmentally friendly. It not only reduces requirement for big-size landfills, but also reduces the use of important natural resources such as river sand. It also reduces greenhouse gas emissions, thus contributing to India's green transition objectives. We are very happy that our colleagues from SINTEF are working closely with the CPWD for several years now. The first phase of the project focused on capacity building of officials from the CPWD. Exposure visits were organized in Norway and Europe to showcase state-of-the-art C&D treatment plants and public buildings made of recycled materials. Pilot demonstrations were taken up in India with key construction companies such as Godrej and Larsen & Toubro, as well as with Goa Waste Management Corporation. They will share their experiences later today. I hope to visit some of those projects soon. Phase 2, started in November 2022, aims to increase the utilization of recovered waste in the building and construction sector in India by increasing the recycling capacity. The project will also develop guidelines for quality management, organize stakeholder consultation, and systematic trainings, as well as implement a few demonstration projects. In Norway, the first national action plan was initiated by the Federation of Norwegian Construction Industries in 2001. Before that, approximately 80% of the construction waste ended in landfills. Now, we recycle more than 80% of the construction waste with a focus on resource and energy recovery. This is partly because the building regulations in Norway require the preparation of waste plants before new construction, renovation, or demolition starts. Builders must also have on-site segregation facilities and deliver waste to approved waste collection facilities. The role of regulations and oversight is central. I'm happy that Norway, with its more than 20 years of experience in construction waste management, can contribute in this important area here in India. I must compliment the good cooperation between SINTEF and CPWD over all these years. With our joint efforts of the Embassy and the Ministry and CPWD, I hope this initiative will reach more and more municipalities and government agencies in India. And I wish you all a successful workshop. Thank you so much.
Thank you, ma'am. Humbly, I request the Honorable Union Minister, Shri Hardeep Singh Puri ji, to share a few words, please.
Ambassador May Ellen Stenner, Manoj Joshi ji, Kaushal ji, Dr. Engelson, friends, I would like to start by extending my very best wishes to CPWD and SINTEF for organizing this workshop on the use and recycling of construction and demolition waste. I think this workshop is an excellent opportunity to gain insights into national and international expertise and the best practices available all over the world in the field of C&D waste recycling. The construction industry in India, as all of you who are associated with it are only too familiar, is seen as a central pillar for the country's economic growth by the current government. The construction industry is amongst the fastest growing industries in India. It is the second largest employer in the country and has both forward and backward linkages across 250 sectors in the economy. The estimation currently is that by 2050, India will have the third largest construction market globally. We are already the second largest producer of steel and cement in the world. If the current trends available in the global economy are any indication, many large economies in the industrialized West are experiencing challenges and are slowing down, and India is becoming an increasingly important destination for FDI in manufacturing and construction. We are building, or rather constructing built environments at great speed. For the last 7 years that I have been associated with this ministry, one of the statistics I am most likely to quote in gatherings like this is a study which I saw produced by McKinsey, the global consulting firm, which says that India is producing between 700 and 900 million square meters of commercial and residential space every year till 2030. If India is going to be a developed country by 2047, infrastructure will be a vital component in our ambition. And I also want to share with you a personal thought that the methodology for analyzing the Indian situation that we use very often overlooks some special features of the Indian economy. We are a large economy, but with developmental challenges. Our per capita incomes are very low by global standards, but they are picking up very quickly. Also, our urbanization, which was largely a neglected segment of the economy till 2014, when the Honorable Prime Minister took off, is now receiving increased attention. This is brought out if you look at the overall expenditure being incurred by the central government on its schemes. I very often, like the McKinsey study I also quote that between 2004 and 14, all the central government spend on urban space, so I'm not counting the private sector, was about 1,57,000 or maybe 1,70,000 crores if you look at the contribution of the states as well. And in the 10 years of the Modi government, going forward from 2014 on now, it is more than 11 times that. Also, some of the infrastructure projects are of course those which were the requirement. Building a new parliament, the old parliament was conceptualized in 1916. It started construction in around 1920, was built in a few years after that. It was never designed to be the parliament of an independent, sovereign and independent country. It was designed to be the imperial legislature of a colonial dispensation. New Kartavya Path, Bharat Mandapam, Yasho Bhumi. Apart from those, if you look at the expenditure, or rather the sheer figures on the highways, the airports. So construction and demolition waste in India has to factor that amount in, and in addition to that, the fact that much of the construction which took place after the 50s, 60s was not conforming to a plan. It was not built for the future. Much of Delhi, which was constructed in the 60s, I suspect has to be rebuilt, and quickly. And it's already something which is in India. And as Secretary explained, I think very clearly, what was the tendency earlier? If you didn't have a scheme in place, somebody would have your waste, dump it outside the city limits. All right? Now that there is an increasing consciousness which is on the environment, which is also on the waste to wealth route, now we are putting in issues place. I'm very happy. I think when the Honorable Prime Minister assumed responsibility in 2014 May, I think the amount of waste we used to reprocess was about 16-17%. Now we are talking about 78%. And I think in the next 2 years or so, we are planning to take it to 100%. So workshops like this, where you have a chance of exchanging views, learning of other practices, and collaboration. And it has to be, it's not an altruistic exercise. I think there are economic processes involved in here, and the stakeholders have to be made aware of those economic processes so that they can take advantage. I have a very long list of substantive points, but I'm going to request my colleague, Mr. Jain, to put those out on the web or release my remarks, because I think that it only will amplify what I'm saying in terms of facts and figures. One of the 2 points that I do wish to make, however, that the construction and demolition waste in India is one of the largest solid waste streams in the world. Our partners in this workshop, Sintef, estimates that the construction industry in India generates about 150 to 500 million tons of C&D waste every year. This brings many challenges to the forefront, such as unauthorized dumping, lack of space for disposal, improper mixing with biodegradable waste. C&D waste is rarely recycled on a large scale. Clearly, there is a huge demand for technologies that will support waste reduction and recycling waste material. Recycling discourages illegal dumping and reduces the negative environment effect on groundwater, surface water, air, flora and fauna. But I think the most important point here is that once you create an ecosystem that places a premium on incentivization to use that waste for productive purposes, and you produce an incentive for people to want to take advantage of this commercially, I think more than half the job is done. I wish you very successful deliberations. The very fact that I take time off after having got back middle of last night, midnight, and I have a very packed program, it's because I think all my colleagues in the ministry and all our other NBCC, CPWD are all give the highest priority, whilst your deliberations will be a collaboration between CPWD and Sintef, but I think the other government associated agencies would be very happy looking at it and profit from it. Thank you very much.
Thank you, sir. That was an amazing speech. And I think we've learned a lot. Can we have another round of applause, please? May I please request the Additional Director General Tech, CPWD, Shri Naimuddin ji, to thank our dignitaries for their invaluable presence.
Honorable Housing and Urban Affairs Minister, Shri Hardeep Singh Puri ji, Her Excellency Maylin Stiner, Ambassador of Norway, respected Secretary, Housing and Urban Affairs, Shri Manoj Joshi ji, respected Director General, CPWD, Shri Rajesh Kaushal ji, respected Dr. Christian John Engelson, Professor, Chief Scientist and Project Director, SINTEF, senior officers of the department, invitees, speakers and participants. It is indeed my privilege and honor to present vote of thanks on concluding moments of this inaugural session of this day-long workshop. We express our profound gratitude to Shri Hardeep Singh Puri ji, Honorable Housing and Urban Affairs Minister, for gracing this workshop. You are head of our family, sir, mentor and guide. Under your direction, we chalk out our travel path, devise our strategy and manage our resources. Sir, we are confident that under your benign leadership, CPWD will give its best to the nation. We have confidence in ourselves, and with your kind support and guidance, our resolve and determination, we will touch new heights. We express our sincere thanks to you for spending few moments with us. Your very kind words and advice and guidance shall go a long way in boosting our morale. We are thankful to Her Excellency, Ambassador of Norway, for her kind words of the advice and guidance. Your presence here and words of support shall go a long way in boosting our confidence for Indo-Norwegian relationship. We would like to express our sincere thanks to Shri Manoj Joshi ji, Secretary Housing and Urban Affairs, for his kind presence and words of guidance and support. Sir, CPWD under your able guidance and support is committed to work for sustainable development, and we assure you that with this available institutional and personal acumen, CPWD shall further strengthen its effort to execute works with less dependence on water and natural materials, with zero construction and demolition waste policy, and by using new technologies, materials and systems based on renewable resources. I express my heartiest thanks to Shri Rajesh Kaushal ji, Director General CPWD, for his lucid narration and sustainable development initiatives made by CPWD and use of C&D waste products and items in CPWD works. Sir, without your determined efforts, it would not have been possible for us to organize this workshop. And we are confident that under your dynamic leadership, CPWD shall give its best to the nation. I am also thankful to Dr. Christian, the flag bearer of the SINTEF in India, and our collaborators for this workshop. Sir, I am thankful for your initiative, commitment and endeavor to cause this workshop. We look forward for more with you and a long way CPWD SINTEF relationship. I am thankful to all the speakers, invitees, participants from different organizations and construction industry for their presence in this workshop. I am also thankful to team of the officers and staff who have worked out the minutious details in the successfully organizing this workshop. I express my sincere thanks to all of them. Last but not the least, I am deeply thankful to the team of the Vigyan Bhawan, security personnel, press and media, officers in charge, and all other members who have worked hard to organize this workshop. Now I request everyone to join us for the next technical session. Thank you. Jai Hind.
अभी मैं क्या करता हूँ, ये हो गया ना, अभी हमें ये मन है नाम तो नहीं है। Good afternoon, everyone. Let us begin the workshop. Can we please have everybody seated? Thank you. I would like to begin the workshop by inviting Shri S.P. Chaudhary ji, SDGC PRND, to please honor us by chairing technical session 1. Ji sir, okay. उन्होंने बोला वो है ही नहीं, इसलिए उन्होंने बोला ये तो है ही नहीं, इसलिए उन्होंने बोला अभी तो है ही नहीं। अच्छा, may I please invite Shri S.P. Chaudhary, SDG PRND, to please honor us by chairing technical session 1, where his expertise would foster insightful discussions among other esteemed participants. For the second step, may I call upon Shri Rajesh Bankarji, Chief Engineer, CPWD, to kindly do the honors of co-chairing the technical session 1. May I request Shri Prem Mohan, Chief Engineer, CSQ, I beg your pardon, Civil, to please felicitate our chairman for the session 1. And I'm also humbly requesting Shri R.R. Meena ji, Chief Engineer, CSQ Electrical, to kindly felicitate our co-chairman. Thank you, sir. So,
we had just an envelope session. The time was little extended. The scheduled time to start the technical session was 12:40, but now it's already 1 p.m. So we have little less time. So in this session, technical session 1, we are going to have 4 presentations. I hope all 4 presenters are available here, present here. And the topics which are chosen for technical session 1 are very relevant. The first being related to the waste 2016 guidelines, rules, and notifications have already been issued by Ministry of MOEF CC. And then another 2 presenters will make their presentations on the actual use of C&D waste products in their projects. And the last presentation is regarding economic model on C&D waste materials. As we have the short of time, so I request all the presenters to have brief on their presentations. The available time is little less than 15 minutes. Earlier we had 15 minutes considering 1 hour time available for this session, but I hope the session has to be closed, I think by before 2 p.m. So I think we can give 12 minutes to each presentations. And because the actual presentation may take more time, so I request the persons to restrict to the important points so that the audience can focus on those important issues. So we have Mr. Naga, co-chairman. So for that monitoring of the times, I hand over to Mr. Banga. Thank you.
So since we are already 20 minutes behind schedule, I request the delegate from Ministry of Environment to start his first presentation. Though the designated time was 15 minutes, we expect the speakers to be around 12 minutes. So after 10 minutes, I'll be giving a reminder that they should try to finish in next 2 to 3 minutes. Thank you.
may I please call upon Mr. Bharat Sharma, a graduate of NIT Hamirpur with a BTech in Civil Engineering and MTech in Energy, I beg your pardon, and Environmental Management from IIT Delhi. Currently serves as a member secretary of the Central Pollution Control Board with a tenure at CPCB since 1997. May I please have you on the stage, sir?
Good afternoon, the chairperson and the co-chair, ladies and gentlemen. Thank you for giving opportunity to us to share the regulations on construction and demolition wastes and the current status. So I would quickly try to finish within that 12 minutes of time. Next, please. Now, if you see at construction activities, the activities itself contribute a lot of air pollution. It's a concern, especially during winter and summer, both seasons, particularly high in winter seasons. And when it comes in the form of the waste which is generated during these activities, that also contribute to the air pollution, but more than that, it contributes to various environmental degradation, especially illegal dumping to the low-lying areas, especially on the floodplains, and as a result, it is changing the course of rivers and affects the quality of the rivers also. Mohua has given an estimate of somewhere close to 100 million tons of generation of C&D waste per year. Of course, it will depend upon the type of urbanizations which has different growth in various cities. So overall, we can say that yes, in the country, it is generated 100 million plus C&D waste, and it's a challenge for all of us to manage those C&D wastes. And Government of India has notified Construction and Demolition Waste Management Rules 2016 under the Environment Protection Act. And I'll just quickly go through the various responsibilities that has been given under the rules. Next slide, please. So it talks about, firstly, the duties of the waste generator. Okay. Thank you. So the rule stipulates that it is the sole responsibility of the waste generator for collection, segregation, and storage. Then it has a little bit higher responsibility towards bulk waste generator in the form of 20 ton per day or 300 tons per project per month, to have the approved plan in hand before the C&D activity is being taken up, and that is to be approved from the ULBs, the concerned municipal corporations. Then the various service providers who provide services of telecom, electricity, who often goes for road excavations and on the site, the construction activities, they have also been envisaged with the role of preparing the waste management plan, and they have to remove that from the site. Next slide. Similarly, it is the role of the local authority to sanction those management plan, to set up the collection center, the transportation mechanism within their jurisdiction, and over and all, keeping track of C&D waste generation. So this is a very basic thing which starts from the foundation of the C&D waste management, that unless the track is there, the inventory is there, perhaps which will help in developing good policy for the city about the generations, the capacity required, the transportation and collection centers. So that's a very basic responsibility that has been assigned to the local authority. And then State Pollution Control Board has been given the duty to enforce the provisions of these rules in the respective states. And state government and the union territories has also been given responsibility to come out with the policy document on overall management of C&D waste in the state, and also to set up these facilities in the state. The other important point which has been stipulated in the rule is that the municipal and government contracts have been mandated to use at least 10 to 20% of C&D waste to be processed and used in their respective constructions. Next slide. Similarly, CPCB has been given to prepare guidelines and collect and compile the data in the form of annual reports, what we receive from the State Pollution Control Board. And the State Pollution Control Board is to generate this data from the ULBs. And the other important role that has been assigned to the Bureau of Indian Standards and Indian Road Congress is to come out with the code, that is the specifications of recovered materials from the C&D waste, which will help the end users to use that systematically. Next slide. Now, as far as CPCB is concerned, we have come out with the guidelines on construction and demolition dump sites and waste processing facilities. These guidelines are available on the CPCB website, which mainly focuses on pollution control measures, as well as a little bit on technology aspects also. And BIS has also come out with the standards. If you can click on the hyperlink of the BIS IS 3832016. Okay. Can you click hyperlink? No, the back one. IS 363, yes. This is the IS code which has been given by the BIS. You can see that RCA has got good potential of using in M15 and M25, whereas RA has got potential of using 100% in less than M15 grade. Back, please. Go back to the slide. Similarly, the Indian Road Congress has also come out with its own code for using in the road constructions. Next. Now, coming to the informations what we have received, these are all the reported informations. It's not that if it has been quoted here that the generation is around 29 lakhs ton per annum, it doesn't mean that the country is generating this. But yes, only 9 states have reported so far, and that reporting is also to be seen that whether it comprises of the entire ULBs within their jurisdiction. So far, as compliance of the rules, 9 states have reported some 29 lakhs tons of waste generation and collection of around 2.8, processing of 6.4 ton per annum in Delhi. And 7 states have got the policy in hand, in place for management of C&D waste in the state. As far as processing facilities there are 31 operational facilities in the country, and there are 26 which are to come. Can you please click on the operational 3.1 hyperlink? Just to give a fair idea to the audience that these are the 14 states. You can see that Delhi has got the highest one with the capacity of the generation which has been reported, and the processed also. Go back. C&D waste processing technology mainly comprises of wet and dry processes. Back please. Typically, this dry and wet processes comprises of shredding, the sieving into the various sizes, and it involves the use of water also, so that dust emission doesn't take place. And during the crushing also, it is being used, some water fogging and all those things, arrangements are being made within that sieving machine. Next slide. If you look at the management in Delhi, so we have 5 C&D waste processing plants which are installed way back in 2009, and more recently in 2015 to 2016. We have the capacity of 1,000 to 2,000, 2,500, and even a lesser one at Mundka, 150. 2 minutes, right. So overall, these facilities have processed so far is the 90 million tons of C&D waste in Delhi alone. Next. So these are the challenges. Quick, just the important point which has been talked in the morning session, inaugural session also. As I said, that inventorization of C&D waste is must, which has been envisaged to the ULBs. That has to be done for effective management in the city. And next is the collection centers are to be established. This has to be put at a place where the generator feel that instead of dumping into the rivers or other illegal places, this deposition at this collection transportation would be cheaper. Perhaps that those things are to be taken into account while setting up the collection centers. And C&D processing waste facilities also requires to be expedited in the respective states. RA recycled aggregate and recycled concrete aggregate, that needs to be prioritized. I was discussing this morning with few of the persons here in the gathering that the cost is one of the important aspects, the demand and supply. Sometimes the quality doesn't meet, so there is a less, that affects the demand. But in Delhi, I've been told that the quality is being met by all those 5 C&D waste processors, more or less. Yes, the cost is there, cost is a concern. And lastly, but not the least, is the awareness among the janitors as well as the public, which will push these requirements to be put in the place. And I would like to conclude by saying that there is a discussion also going on in the Ministry of Environment and Forest to bring this C&D waste into the EPR regime, that is external producer responsibility regime. So far, EPR regime has already been notified in case of plastic wastes, electronic waste, tire wastes, and the battery wastes. And wastes are now being channelized for those processing, and the producers are being asked to meet their targets of whatever the waste being put into the market. So on similar pattern, the discussion is going on to bring this EPR framework on C&D waste also, wherein the producers, that is the construction agencies which are carrying out the constructions, they will be given some target to use C&D waste, and to get the C&D waste used, recycled and used in the construction, and maybe that obligation has to be met by this. So these are all the discussions which will, I'm sure, which will, if it gets materialized, it is going to give a big thrust to the C&D waste, which is being generated in the tunes of more than 100 tons per annum in the country. Thank you.
It's a special purpose vehicle created by Government of Goa.
A very good afternoon, Chairman sir, Co-Chairman sir. I have to now rush against the speed at breakneck speed. So I'll see how best I can do justice to both. Goa Waste Management Corp. Okay. So the topic is best practices in municipal solid waste management in Goa. See, responsibility of waste management, now this is relevant for C&D waste because there are 2 separate streams, they cannot get mixed up. So I will just dwell upon the municipal solid waste first, and the last 2 minutes I'll speak about the C&D waste initiative in Goa. So whether the panchayats, local bodies or municipalities are well equipped to handle this waste is a big question to be dealt with. So Goa Waste Management Corporation came into being 2016. It's a special purpose vehicle, and we deal with the common facilities. We have set up 2 municipal solid waste plants. We have set up biomedical waste plant. We have set up your hazardous waste plant, and e-waste plant is ongoing, and C&D waste will be set up very soon. Now, see we had one of the first act in the country, the Goa Non-Biodegradable Control Act, in which there was segregation, all those issues were discussed. But until the rules came 2016, nothing really worked on the ground. And now we have a system in place. We also have the issue is putting up plants is not a big issue, but to make it work is very, very important. Our North Goa plant, see, these are the state of Goa is a very small state with only 2 districts. This is the districts of various type of waste which is generated in the state of Goa. The thumb rule is for state of Goa, it is 266 about grams per person, but we get almost about 466 because of the disposable income, higher disposable income, and all those other things. So we have set up various plants municipal solid waste plants, and now, as I said, C&D and e-waste in the. This is our plant which has been set up for the first plant at North Goa, Saligaon, which is 250 tons per day capacity plant. It generates electricity, and I can proudly say this is the only working plant in the country working for the last almost 8 years, generating electricity. 50 to 60% we export to the grid, and otherwise the rest is utilized in-house. So it was 100 tons per day, it is now expanded to 250 tons. So these are the various parameters. 0.8 megawatts were produced initially, now 1.3 megawatts power is produced from this plant. Plus we are also having 0.5 megawatts of solar power also generated there. This is our biomedical waste plant, one of the latest technology that has been adopted there. And all these projects are on PPP mode. They are on PPP mode, and successfully we have been able to put these plants there. This is a biomedical waste plant. This is our hazardous waste facility. There is landfill as well as the incineration part. Now, how did we put up these plants? We had dumps like all over the country. So the policy adopted by government of Goa was you remediate the waste, legacy waste, and then set up the plants there. So both the plants have come up on the erstwhile legacy waste dumps. All the fractions were separated and they were disposed of scientifically. So these were all the dumps. Of course, our dumps are not as big as the dumps maybe in other parts of the country. So we also do a lot of highway and major district road collection. Humanly, it is collected along the roads, and then the waste is channelized to our. This is what we do. These are the transfer stations, because people go on dumping waste, and there cannot be a policy of any government or government in the world to go on collecting and people go on dumping. So now we are in this process, so that the effort of people to come and dump it on the road is at least channelized to these places, and then it is scientifically disposed of. So from schools, we collect waste for waste segregation, all the school complexes. It is again channelized. Beach collection also takes place. So as I said, existing dump yards were remediated, and on that the projects were put up, which are like brownfield projects, not greenfield projects. Now, what are the challenges faced? Land is again a big issue in the state of Goa. In fact, for C&D waste, now we had some land issues. We are in the process of solving that issue as of now. So now the success story for waste management, as municipal waste management in Goa. The facility generated employment to the rag pickers. There were about 140 rag pickers in those dumps. We channelized them, and they were put to work there because they had the core competency. During COVID and all that, it continuously worked. There was not a single day it was stopped. The funding for this project was we obtained from NABARD. That time 2.7%. It's very, very important because we linked the compost generated out of these plants, and that's how to the farmers, and then NABARD funded us this. This is the details of the electricity generated. This is the night view of the Saligaon plant. Goa is known for tourism. Please visit us to see these facilities. So these are the various things: material segregation and recovery, the component, dry, wet waste fraction. There are separate lines, and now in the countries, there are rules, waste management rules. We have to have separate composting line, biogas line, and sanitary landfill. Now we are thinking of making CBG out of this. We have to come out of that concession. So these are some of the pictures. Odor control is still issue. I would like to know if somebody is there who has managed better odor control. We have done to a great extent, but still there are some issues. These are the biogas. This is which is added. Goa, we get minimum 8 to 9 months of clear sunlight. So these are the solar sheds where compost is dried, and relatively good quality compost we get, about 8%, 5 to 8%. Now, how these plants were put up was with debt of 75% and 25% equity of the concessionaire. Of course, the rates were very high. During COVID time, the bank interest came down, so we restructured the loans. Now, similarly, the Kakora plant in South Goa, just 2 weeks, on 6th of this month, Prime Minister has inaugurated this plant. And again, it will be funded by NABARD. Now, construction and demolition, this is the one waste which we have to put up. Of course, there were some issues of land. We have worked with Sintef. We have signed MOU with Sintef. And existing quarry, laterite quarry was identified. And there we are going to set up for various products like sand, your pavers, and so many other things. In this, very critical is that the products made has to be purchased, especially by the government sector, so that it is made viable. Now, what we did is, as of now, there's a temporary quarry which has been, we have taken permission, and we store all the waste, C&D waste as of now. And there's this setup as of now there. Now, this is a very interesting thing. Goa has got a lot of laterite. So, when you extract laterite stone, there's a lot of laterite sand or loose sand available. So, we thought of making a product out of it. It is lying everywhere. So, this is the product. This is the brick which we made out of laterite with about 10 to 12% of cement. And a homogeneous sample was taken from various parts of Goa. We brought it to Delhi in 2 trucks, and then at your Shastri, this one, yeah. So we process it, and this has been done. We have applied for patent, and the final hearing took place about 2 weeks back, and very soon I'm hopeful of getting this patent given to us, which will make a big replacement in the building industry in Goa. So that's all from me. I have just to thank you.
Giving us bonus of 2 minutes. Thank you. So our next speaker is Shri P. Bhagat Singh, Chief Engineer, CPWD, who will be speaking on use of recycled materials in CPWD.
It is not changing. In the meantime. Yeah, it's not changing.
Good afternoon, everyone. Morning, someone was asking me, are you attending the waste seminar? So I thought he was just joking. I just gave a smile, but he persisted, and I felt that he really meant that it is not going to be really an effective seminar. So he felt a lot of repetitive content will be there and ineffective content will be there. So probably to some extent he was true also, until and unless we get a confidence about the applicability and viability of reuse of C&D materials. People tend to think that way. So then I politely told him, yes, even presuming it is a waste seminar, so I said I have my own methods of segregating what is waste and what is useful material, and I can recycle the useful material into my mind also. I think we all with the collective endeavors, whether it is seminar or whether it is real physical C&D recycling waste, so we can adopt an approach that something useful can be extracted out of waste. This is the broad scenario in the Delhi city. Please don't look at the absolute figures. Our idea is to understand the relative perception. I will try to focus on the row number 4. The total waste processed, it is 2,365 tons per day, which is only 38.3% of the waste generated and 47.3% of the waste plant capacity. So many a time we tend to think in places other than Delhi. Delhi's scenario is better, but in other cities this infrastructure is not there. But lack of infrastructure alone is not the limiting factor. There are certain other economic and technical factors also there, which are limiting the use of recycled waste. And we are proud to say that so far as Delhi construction scenario in CPWD is concerned, almost more than 90%, if not 100%, the waste that is generated at construction sites that we are processing through recycling plants. So other data I am skipping. This is the waste recycling plant. CPWD has huge role, and Of late, one of the thrust areas has been C&D waste recycling. So you may look at the last row, which shows the annual target for 2023-24 set by our own ministry, that is 110,000 metric tons of C&D waste processing and recycling. And again, we are proud to say that that target we have almost achieved up to mid-February, 97,870 metric tons. These are the materials which we recycle out of C&D waste. Few case studies, not precisely case study, but some information we would like to, I would like to share with you. In some of the projects we took up at Delhi. There is one redevelopment project for housing. The huge, large number of colonies located in the heart of the city, we felt that space is not efficiently utilized. Scarcity, there is always a scarcity of land in the heart of the city. And they are low-rise buildings. So 4 colonies are identified, and there are total 4,860 residential dwelling units, which are redeveloped as multi-storied buildings, and 9,967 units were constructed. Some colonies still are under construction. These are the images of the colonies already developed. Huge quantum of recycled products are used in this redevelopment project. The figures are shown at the bottom. Almost 34,300 metric tons of waste was generated. And out of that, approximately 10,000 metric tons of recycled products are used back in the project. In many projects, we are not in a position to reuse the recycled products in the same project, but somehow from the recycling plants, it is going elsewhere in other projects in the city. So these are reused at construction site in the form of block masonry, tiles, and curbstones. These are individual images. Somewhere they are used in boundary walls, and in mostly C&D blocks. Here, curbstones are used on pathways and footpaths. Again, in toilets and other guard rooms. This recycled aggregate is used in base course in seaways and drainage areas, and also in footpaths. These are few images. In this particular redevelopment project, we also ensured enforcement through contract provisions. Various contract provisions are mentioned in the contract, so our enforcement could be more effective. And some constraints also we observed in use of recycled products in terms of technical adequacy and strength also. So the research is going on in this aspect. So all these aspects we need to address. Another project, which is additional office complex for Supreme Court of India. This is very huge, big project, big building. Here again, mostly C&D blocks of size 400 by 200 by 100 mm were used. Almost 18 lakh blocks were used with a strength of M10, water absorption 10 to 12%. So these are few images of actual use. Testing, actually the IS codes need to be evolved to precisely cater to the C&D waste. But as of now, in absence of such codes, existing codes we are using for regular concrete blocks, and we are testing. So in Central Vista project also, on a large scale, we have processed the construction demolition waste. This is the new Parliament building, almost 5,000 tons we have processed through recycling plants. Another Central Vista, part of the Central Vista project, 10 Central Vista Secretariat buildings are being taken up. So first 3 buildings are under construction, each building having 1.5 lakh square meters of plinth area. Considering various projects in the Central Vista project, total 78,892 metric tons of waste was generated during last 2.5 years, and entire amount has been sent to the processing plants and recycled also. And approximately 10% only we could reuse in the same project. Rest of the recycled products are sent elsewhere. So here, this is out of C and D, the first letter C, construction waste. few little examples we implemented in new parliament building. Lot of waste ply is generated during construction. Those are effectively utilized for preparation of signages during construction and other planter boxes and those kind of things. This is again not the demolition waste, this is the construction waste which is reused at site of work. Like fly ash bricks are used for protection of plants, waste concrete is used for making molds for effective site management, and even steel is also used wherever holes are there for covering up from safety point of view. And also certain other uses. There is another executive enclave. This is a big building complex housing Prime Minister's office and other senior establishments of the government of India. Here again almost 20,000 metric tons of recycled concrete blocks are used in the building. So this fact is important because many a time we may be under impression that these are not reused. These are used only in relatively less important buildings. But the point we are trying to convey is executive enclave is the building of topmost importance, accommodating Prime Minister's office and other important buildings. There also. So common central secretariat buildings also 25,000 metric tons is processed and 11,500 is used back in the building. So having said this, these practical instances instill confidence in the minds of whoever has had to use recycled products in their projects. The idea behind showing this information is to instill confidence in their minds. But we all know we have a long way to go, and we also understand the constraints involved. There is need for more awareness about environmental responsibility. So this is precisely why we are holding these kind of workshops. So adequate C&D waste collection centers. Delhi is a good example, but many other cities, a lot of establishment needs to be done. Regulatory norms. My previous speaker has explained. Apart from Pollution Control Board and BIS, CPWD has also issued several statutory guidelines which are followed by various departments all over the country. Contractual provisions need to be, ma'am, I think morning Ambassador Norway was rightly mentioning, we need to focus very much on segregation of waste at the source, that is construction sites. That is one area we need to focus, because among all, apart from the technology required for recycling, segregation is the most important aspect. So, and last but not the least, ensuring reliability of recycled products through testing and certification. So I think all these I will skip. These are all the various regulatory mechanisms. In CPWD, some circulars and instructions are issued from time to time. And BAS guidelines are there. Thank you. So, thank you.
From RTI. So by the way, this RTI is not Right to Information Act. This is Research Triangle Institute.
Namaskar. Good afternoon. First of all, thank you to CPWD for inviting us, and of course, CENTEF, my dear friend Christian is here. So, a lot of things have been said. I will try to be fast and come to the core of the issue. As you know, Mantriji said this, we are growing very fast. Indian economy, is growing at 7-8%. And he also noted that infrastructure development and construction industry are a core part of that. Here are some numbers. This is the National Infrastructure Pipeline, which has projects worth 1 lakh crore. 5-year pipeline, and as you will see, a lot of this involves construction. And therefore, naturally, construction and demolition waste. But also, therefore, issues of sustainability come in. There was talk a little bit about, urbanization, and the official statistics say that, India is about 35% urbanized. But the reality is that we are actually much more urbanized. Research Triangle Institute, we have done studies which show that, India is maybe 55% urbanized already. And when you look at the quality of air quality in our cities, it is amongst the worst globally. And construction processes, including, transportation of waste and dumping of waste, contributes a lot to this. So environmental sustainability as we move forward, growing our economy, is becoming an increasingly important agenda. And therefore we need to start thinking not only about economy, but about circular economy. We're also concerned, as you know, that availability of materials for our construction is becoming a concern. Our natural resources are depleting fast. And if we have an opportunity to reuse the materials, then why not? Depletion of material also means that the cost is going up tremendously. Globally, the prices of sand have increased much higher than the normal inflation, almost 2x. And the same applies in India as well. So therefore, we need to start thinking about sustainable development goals as we go forward. Today, we are the country with the highest population. We're also one of the youngest countries globally. The average age of an Indian is 29 years old. And therefore, the aspirations and expectations are much, much higher. They are going up and up. So we need to start thinking in terms of circles and circular economy, and not traditional ways of thinking, of use and throw. And the good news is that the recycling technology is available globally and in India. And I have had the pleasure of, having seen it very closely. Some of my colleagues, both on the side of developing this technology and on the side of operating this technology, are in the room. This is an extract from a manual which I developed 5 years ago, which documents various processes, various tools, equipments. Bhagat Singh ji was talking about segregation. So how do you deconstruct? How do you segregate materials? This manual was developed and is available. Earlier, CPCB member secretary was talking about, 31 operating plants in India. But actually, if you look at the regulations, which secretary also mentioned about, the regulation says that every city should have had an operating recycling facility back in 2019. But we have only 31 operating today. So we need to do a lot more to be where we want to be. I'm happy that CPWD is taking leadership in this, because CPWD, being the national organization, and your brochure, very nice brochure today, talks about CPWD being vigorously involved in creation of built environment in almost all cities. So that's great. So when you are building up cities, demand from the cities that this recycled material is available not only in Delhi, but everywhere. Why only in Delhi? And to that extent, I'm happy also that Goa is here. We have been collaborating with Goa, trying to develop a model of how it can work in cities. So Goa has shown that solid waste management can work. And we have collaborated with Levinson ji here to develop a model of how C&D facilities can work. Because as you have seen, technology is available, rules are available, but it still doesn't happen. Only 31 cities have an operating facility. And the reason why it is not working is because we don't have an efficient, economic, sustainable model. So what are the components of such a model? We have thought it through. And we have realized that, there are certain key principles of making such a model work. What are the key principles? The key principles are that you need to have polluters to pay. You can't let them just dump. But since dumping has been going on, how do we make sure that dumping stops and they start paying for recycling? So we have to do it in such a way that at least initially, when you are asking polluters to pay, we ask them to pay little less than what they are paying for dumping. Because when they dump, then also there is a cost. They will get a tractor trailer or a truck to come and they will charge something. So if you ask them to pay little less than that, then they will have an incentive to send their waste to a facility. We have seen even these 31 plants, many of them don't receive the material because people are still dumping. Then you need to make sure that the products which are being generated are picked up by the users. And again, they have to compete with products from natural aggregates. So again, can we price them little lower in order to ensure that recycled materials are utilized? And if you do that, we find that it is possible to make it work. But in the initial years, state government has to provide some support. And that support has to come to make sure that the recycling facility is always operational. So we developed this model for Goa, and these numbers are specific for Goa but can be worked out for different cities. We found that the total investment required is roughly 50 crores for a city/city-state, which Goa actually is, about 50 crores. And you need some operating costs, about 10-11 crores every year to make it work. So total cost comes to about 20 crores, the annualized capital cost and the operating cost to roughly 20 crores on an annual basis. So we said, if you have to make it work, you need to recover this cost in 3 ways. Number one, you charge a tipping fee. That tipping fee has to be little less than what the cost for dumping is today. You have to recover some from the product sale, but the prices of products need to be little less than the market price of alternative natural products. And the gap, the gap has to be filled up through an annuity. And Levinson ji explained that even for solid waste management, they have been doing exactly the same process. And that's how for continuously 8 years, you have had excellent operation. So same principle needs to be adopted by other cities. There are many cities where plants are there, but they are not working because they have not adopted a good, sound economic model. So this in summary is the model. Because of paucity of time, I will move forward. And I did some calculations, which are relevant even for in situ facilities, which developers like CPWD and your partners, contractors can use, because technology is available to do in situ recycling as well. So what do numbers look like, if you do in situ? The cost is actually much, much lower. We found that in such cases, because the waste does not have to be transported, which is a big cost, moving it up and down, the cost of recycling in such a in situ plant is roughly, comes to about 600 rupees odd per ton. Of course, these numbers these are illustrative, but I have used the kind of costs, which a typical plant would cost and, would operate roughly 200 odd days, recycling about 100 tons per day. And we found the cost was about 600 rupees per ton. And if I used, this is the last slide, sir. This is for CPWD. I have added this slide. And I used very conservative numbers of the recycled materials to say what will you save, actually. And using a very conservative approach where only about 40% of the materials are high-priced material and about 60% ends up as almost zero cost, we found that the savings would actually equal or exceed the investment required for such a facility. So it is a self-sustaining, almost zero cost, maybe even positive costs for, operating these facilities. So I will encourage, CPWD to look into in situ applications in cities where a recycling facility is yet to come up, CPWD can take up leadership as the premier organization in the country. Thank you so much.
So with this, all the 4 presentations have been completed. I request co-chair Bangaji to sum up.
So first of all, I hope the speakers don't hate me that I restricted them to their time. And anyway, it has been an interesting session. The first speaker, Shri Bharat Sharma from Ministry of Environment, has clearly told us that there is a well laid down policy and rules. So the policy framework is already in place, which needs to be followed. The second presentation was Dr. Levinson Martins from Goa Waste Management. They have, in their state, showed us a mirror, an experiment by which they have followed the energy conservation methods and generate waste usage methods by converting into power and other innovations in their state. And what was interesting was that used it down to the school level and to the village level. So it is people-centric. The third presentation was Shri Bhagat Singh, our colleague in CPWD. He has shows us the various materials which we are using, have started using in CPWD. These are not only in DSRs, these have come up in usages in fields and we are widely using it. Although these are still 3-4 materials, but we need to expand their usage and we need to expand our confidence in the usage of these materials. The fourth presentation has been very interesting. Dr. Gaurav told us that all these efforts would be more practically adaptable if we start thinking about not as the traditional economy usage, but as a circular economy usage. So, and other ways of restricting transportations so that it becomes economically viable method. So the going less destructive matter becomes the most economical method also. So that is the message he conveyed. So with this, I thank the speakers to restricting to their time schedules, and we thank our chairman, sir, to have guided us, and we thank everybody in the session who have heard us with good attention. Thank you very much.
So in the last, we had 4 presentations and all 4 have been presented. So it was 100% presence. And all the officials have made sincere efforts in presenting their informations. So we congratulate and thank them for nice presentations. With this, we'd like to close this session as technical session 1. Thank you. Over to you. Thank you.
So may I please request you to felicitate our esteemed speakers. Chairman, sir, can we please have Mr. Bharat Sharma on the stage? Can we have a round of applause, please? Can we have Dr. Levinson Martin on the stage, please? Chairman, sir, may I please request you to felicitate Mr. P. Bhagat Singh. Sir, could we have you on stage? Dr. Gaurav Bhachiani, sir, may we have you on stage? Thank you, sirs. We all need to fuel our tanks to carry on the workshop. So let's meet in about an hour's time. Let's reconvene at 3 o'clock. Thank you so much for your patience. We are meeting for lunch at Atrium on the ground floor, please. Everyone, may I request you to please be seated so that we can begin. May I please request everyone to be seated so that we can begin? Good afternoon, everyone. They say food is not just about eating. It's about feeding your body and mind. A well-nourished mind leads to clearer thoughts and better decisions. So welcome back, ladies and gentlemen, and let's now move on to the next session of the workshop. So for that, I would like to cordially invite Dr. Gaurav Bhaitiani, Director RTI, to please chair the second session. And may I humbly request Shri Ramdayal G, Civil Engineer, CPWD, to co-chair the second session. Ladies and gentlemen, expressing gratitude is a wonderful way to begin any endeavor. Hence, I invite Shri Prem Mohan Ji, Chief Engineer, CSQ Civil, to please facilitate our chairman for the session 2. Sorry. Humbly requesting Shri R.R. Meena Ji, Chief Engineer, CSQ Electrical, to please felicitate our co-chairman for session 2. Thank you, sirs. With your permission, sir, I would like to call upon our first speaker for session number 2. That would be Dr. Christian J. Engelson. Sir, please. Can we welcome with a round of applause, please?
Water available? Okay. Yeah, there it is. Okay. Okay. Thank you again, distinguished guest on the dais, ladies and gentlemen. I will try to give you a taste of the recent development with recycling and use of construction and demolition waste. There are, as I showed in the inaugural session, there are a number of pilots, good pilots. These are mostly taken from Norway, but a clear eye will also see that there is pilots from India. And we will hear a little bit more about those a little bit later in this session. If we are looking at the circular economy or the circular material economy, I like always to say that the most important thing, or one of the most important pillars in circular economy, is to have the material in a never-ending flow. So if you go and look at sustainable concrete materials, there is a lot of smaller circular material economies that is adjacent to this whole CE of concrete. And the reason why I show it is that it's very important when you look at the C&D waste generation and what you can use the C&D waste to. All these smaller blue circles are actually playing a role, or C&D waste is playing a role in all these circles, also in alternative binders in concrete, recycled aggregates, of course, in concrete and concrete products, but also in waste-derived materials for clinker production, which we are looking upon in this moment. And also as a binder in cement production, to be a cement replacer or clinker replacer. So this is a quite brand new or new thinking about how you can valorize the construction and demolition waste. I show this because I want to just sum up a little bit of good initiative, technical initiative we have done, and some of them will be emphasized a little bit later by other speakers. This is actually the detailed project report we did for Goa Waste Management Corporation, like Dr. Levinson was mentioning. And in this initiative, I will also highlight the laterite block that was shown by Dr. Levinson, where we found good performance of its strength development. And this was actually done because of a pilot where we shipped 50 tons of Goan C&D waste up to the facility to Shastri Park under leadership of Mr. Sandeep Malhotra. So thanks to this good collaboration, this could actually materialize. So we are very grateful to that, Mr. Sandeep. The others we will have a little bit more in detail afterwards. I will try to continue on new things, and I would like to draw the attention to the collaboration we have with Godrej, where we are actually trying to measure what is the increased CO2 uptake to these solid concrete blocks with construction and demolition waste, where almost 100% of the sand fraction is replaced with RCA. Why is this so important, or why does it actually absorb more CO2, this CO2 block versus the normal block with natural sand? This is due to the most well-known aging mechanism for concrete or cement-based materials, which is called carbonation. Carbonation is known from the ancient times, and it happens when the cement-based materials are in contact with the air, with air, and reacts with the CO2, and it forms a carbonated layer which is colorless, like we see here, by a phenolphthalein or thymophthalate indicator. You can see the pink and the blue area is non-carbonated area. The pink and blue is only because we shifted to a more healthier indicator. The blue is the most healthiest. So it's doing the same thing. So how can we know how much of CO2 is actually taken up in the gray area? That's actually the main thing with this carbonation and this carbonation measurement. So we actually developed a unique technique which we are able to, like we see here, this is experimentally, or this is more theoretically explained reactions. All the carbonating reactions are actually converting calcium oxide or calcium hydroxide to calcium carbonate, portlandite, and the calcium silicate hydrates, and the ethylengite. and carboaluminates are actually being transferred as a function of time to calcium carbonate and other solids in the cement paste. So that's the reason why the CO2 is actually mineralized and captured in cement-based materials. And I mentioned that this special technique we have developed at SINTEF, and we are actually applying on the blocks to Godrej, where we see here with recycled sand, recycled concrete aggregate sand, and a normal block. And we see directly what is actually absorbing more CO2 out of these two blocks. And that is very clearly seen here, where you see the evolution of the absorption pattern of CO2, CO2 uptake percentage of total capacity is on the y-axis, and as function of time. Square root of time, because it's a diffusion controlled process. And we clearly see that this is an increased CO2 absorption capacity on the blocks which are containing RCA. So that's something that is very important in terms of when you do the LCA analysis, and you're calculating the environmental performance in all the stages of these blocks. And this is something we have drafted, and my colleague Miss Marianne would come back to in detail, because she's an expert on LCA and EPD. But this, I think, is quite groundbreaking and will cause maybe be the game changer if the requirements for environmental documentation are in place. So we have talked a lot about carbonation. The other new thing is that carbonation makes the fines of hydrated cement more pozzolanic. And that means if it's pozzolanic, it can replace cement. And replace cement is, of course, something that all concrete and cement industry are after, because of the lack of fly ash and blast furnace slag. So other SCMs or pozzolanic materials are is very, very hot topic in order to reduce the carbon footprints, of course. And if you look at what the normal, this is a slightly different reaction. I will not go in that detail, but just take the main principle. This is calcium silicate hydrate, which is carbonated. And if you do the carbonation fully, you will carbonate it to calcium carbonate. We recognize it here. And to actually amorphous silica gel, which is no more than actually reactive microsilica, which is more known as a very, very high pozzolanic product. So you create, actually by carbonation, you create amorphous silica, and which is reactive towards calcium hydroxide that is produced from the cement clinker upon hydration. So this is the reaction, which is actually hereby proved that this is this should take place if the conditions are in place. We have done recent studies. NCB and SINTEF did a recent study last year, where we tried to carbonate older concrete rubble, and we also had a master student at NTNU. And the takeaway here is that both studies showed only slight pozzolanic effect. And the main reason for this is that you need to separate the cement paste and the aggregate and the sand, natural aggregate and sand part totally, or in a high level, high degree, in order to get the full carbonation of the cement paste. Only then you get a very high reactivity of the hydrated cement paste. And if you look at the last point here, sorry. Today, there is commercial technologies that is, today commercial technologies are existing where you can actually remove 100% reclaim 100% of the hydrated cement. And then this starts actually to be very interesting and actually a viable business case for the recycling industry. And in the new Norwegian Green Platform project, which is a national big project for the road infrastructure industry, I will show you. It will. This project is actually the objective is to test, verify, piloting, and industrializing new climate-friendly and resource-efficient building materials for use in road structure, in road beds, but also in tunnels. And this road structure and road in road beds and tunnels, it also includes a lot of concrete. So what we have done now, which is the latest development in the leg, which contains the development of climate-friendly materials for concrete, is that we have gone into collaboration with a new technology provider in Netherlands called Urban Mining, which is actually, like I said, reclaiming the cement paste 100%. And I will show you this some pictures where you see here the sand part and the aggregate part, and actually the hydrated cement paste. These samples were actually done 2 weeks ago. I mean, almost 50 ton for a full-scale pilot was shipped down, and we did they did the separation, and we were actually allowed to take samples, and which are now under analysis to see how much cement paste is there actually here. Is it 90? Is it 80? Or is it 100%? And how much aggregate, natural aggregate, and sand is it in these two fractions? It's highly interesting to see if there is any cement paste left. And I will end by showing the pictures here. This is the sand fraction, and this is the coarse fraction. And you can see that there is not much cement paste left. So this is very groundbreaking news, where these two parts are going directly into RMC production or element production, because this is coming from already certified natural aggregate going into the concrete's first life, and then are reclaimed because of end of life, or this in fact was scrap concrete. So we knew exactly what gradings that was in, and we also knew where the aggregate were coming from. So the producer of the aggregate was also with us, and when he saw this aggregate, because that was coming from a concrete where the welder was delivering the aggregate, he said, "Okay, I can recognize my own aggregate." So this is something we are eager to convey, or maybe also start implementing in India. So by these words, I say thanks for your attention.
Dr. Christian, for an excellent presentation. Before we invite the next speakers, I wanted to mention one thing particularly. Dr. Christian talked about carbon capture. And some of you may be aware, but not everyone perhaps, that in India we are now going to develop a carbon market. So carbon capture will therefore equal money very soon. So in addition to the benefit of recycling the C&D waste, the projects will actually have additional benefit when India's carbon market, hopefully by next year, is up and working. So with that, let us invite the next set of, next presentation, which is by Mr. Shamindra Nath and also Dr. Siva Kumar. They will talk about the application of recycled materials in large-scale projects. What are the challenges in implementation? So you will hear real-life implementation challenges and experience. So over to you, Shamindra.
Yep. Thank you, Chairman and the co-chairman, and ladies and gentlemen. We have a few very interesting projects coming up in the next few, with the new speakers coming in, and both the projects where we were involved from Sintef, and so I wouldn't go too much detail into it because it will be a repetition, but I will give you a umbrella helicopter overview about the large scale projects. What are the problems associated with that? Yeah. So this is a common site, a very familiar site, whichever city you go, and it's there, here, there, everywhere. And we know this. I don't want to go too much about this. And demolished concrete basically is gypsum, broken bricks, cement mortar, rubble. So it's not just concrete, it's everything mixed together because nothing is segregated. So this is one challenge, definitely. And then while we know that this is an environmental pollutant, we also have to also recognize the fact that on the other hand, the world is staring at an aggregate crisis. So people who are in the construction industry know it for sure that your average distance to which your aggregates are being transported into the city has increased by 15-20 kilometers at the least in the last 10 years. So sand and aggregates is the largest and the second most extracted after water resource in the world, and around 40 billion tons. That's 9 times the size, the crude oil. That is what is being extracted every year. So you can understand how much of natural resources are being depleted for the future generation. This is a very interesting statistic. China has used in the last 2 years more cement than US had used in the last century. So this is not just China. Now you can put other developing countries also, and India, for instance, and East Asia. So there's quite a lot of construction happening, and all this requires natural raw materials. And if you're going to depend only on natural raw materials, then you have a major problem at hand. And this is the statistics again coming from the Indian construction industry. So we know that there is a big issue. Sand is not an unlimited resource, and we are depleting it at a very high speed. So when we say that there is a problem and we have a solution, what is the solution? Of course, we can go for circular economy, which we have been talking about, and the reason why we are here. So it's very simply put, you take the demolished concrete, you have at least 95% recycling and only 5%. Instead of all the 100% going into the landfill, you'll have only 5% going in. That's a great thing because you can go and use it back into the construction. Now, everything looks fine. You have a problem, you have a solution, but why is it not taking off? There should be some reason for that. We even have the IS 383, which has, I will not go too much into this. So we have the Indian standards saying that you can use this concrete to some extent in the structural works and to a large extent in the non-structural work. And a lot of applications have been developed. So we have the CPWD who have really done a fantastic job. I think they have used the maximum recycled materials and given a lot of incentive for the others to follow. They followed a template there. And there are quite a lot of things which we can make out of this, mostly non-structural. If you really see the statistics again, if you look at the cement consumption, 50% of the cement not goes into the concrete. It goes more into non-structural work. So there's plenty of opportunities to use this recycled aggregates. Now, I'll just briefly talk about the two where we have got the other speakers going to come and talk about it in more detail. The first one I talk about is the Godrej Sintef work. A few slides of this has been presented by Christian. And this is exactly one where we talk about circular economy. And this is a very clear-cut case where we have put circular economy into practice. So we followed the demolition. Right from the demolition stage, we did the carbonation of the concrete, documented that. We followed it up with the transportation down to the aggregate recycling facility, and then we did proper sampling, testing, and recorded all the key parameters of the aggregate that is being produced. We made the blocks out of it at Godrej facility. One block we transported all the way to Norway for that carbon dioxide uptake. And after the blocks were made, we put it back into the metro station building in Goregaon. So this is exactly following the whole chain from the old concrete, demolish, recycle, make a product, and go back into the new construction. The second one, which Dr. Shivakumar will talk about, L&T Sidco project. Now, if you ask what is the challenge here, you'll not believe this. The biggest challenge was to get some demolished concrete. We have a plant over there in Thane, but we have concrete dumped all over the roadside, but at the plant, there is no demolished concrete available to be crushed. And we had to actually use influence, talking to the municipal commissioner and the deputy municipal commissioner of Thane to get some demolished concrete so that we can make this product. So this is the kind of situation where we have to find. So the other challenges, I know Shivakumar will talk in more detail. So what are then these are the situation as we speak. So you have a problem, you have a solution, but then there's some mismatch. Everybody knows it's a good thing, and there is a demand for it, but then why is it happening? Why? Because a few points. One is variability. Now, it's okay when you crush concrete from a known source, you know exactly what would have gone into that. But when you are actually taking the concrete from a recycling facility which is handling multiple sources, then you don't really know what is the source of the concrete, whether the concrete has been good, what sort of exposure the concrete had been to. So you need to know the variability. Second thing, the size, the particle size distribution, the specific gravity, and more importantly, the water absorption. One of the key reasons why we don't, the talking point against recycled aggregates is the water absorption. It is not just high water absorption, it is a variable water absorption. So if you had something consistently bad, you can still work around it. But when you have, it is not consistently bad, you have 6% and 8% and 4%, then you've got a problem. So these are the issues which is always talked against using recycled aggregates. Again, we talked about contaminants. There could be sulfates, chlorides. Now, if it is coming from a multiple sources being handled with one recycle plant, then you have that issue. So the customer needs a confidence that the aggregate which I used to make my fresh concrete is not going to further create a problem for my customer. So it's very important to understand what is the level of contaminants in it. And of course, this leads to durability concerns. So you have corrosion, you have carbonation. Carbonation is good for CO2 uptake, but then carbonation is not a good thing in concrete. So you need to also define that. You need to actually quantify that. Alkali silica reaction, for instance, engineering properties. So the strength, it's not just the strength, because you'll get variation. If you have water absorption varying, you'll have a variation in strength. So you need to overcome that problem. You have abrasion resistance. So it's not just about strength, it's also impact and abrasion. There could be quite a lot of other mechanical properties which the concrete will have to do. So this is a major concern, and we need to have a proper testing regime, third-party certification. We have to build confidence to the customers that this can be used and put to use in a good manner. So the biggest problem, I think, is the perception and acceptance. In the morning session, the speakers talked about, are you going to the waste seminar? It's not a waste product, it's actually a resource. So we have to change the attitude, we have to bring in the perception change, and you have to make acceptance. This will not happen just by capacity building. You have to really do some work on the ground to make sure that this is documented and there is a proof in which you can be sure that this material can be used in my concrete. So CINTEF has worked with CPWD in drafting a testing regime for use of recycled aggregates into concrete. Now 383 has allowed to use, but then the guideline for also what are the tests to be followed at what frequency is also important. Then you have a much better understanding about how to incorporate this into your concrete. So this is what CINTEF has done, and it's been incorporated into the tender documents of CPWD. So we have put down the key parameters. What you find at the top is 0 to 4.75, that is the sand. So if you are using a sand, what are the parameters you test, at what frequency, and to what standards? So we have documented that. For example, if you want to do the sieve analysis, of course you need to do one per day, because every day you need to do at least one sample so that you're sure about the particle size distribution. But for example, if you're looking at soundness, you don't really have to do every day. You have to do it two samples in a month, 2 per month. So we have listed down the parameters, key parameters which makes an influence on the cement, on the concrete quality. And this document is available, and the idea is to take a pilot project again with one of the RMC companies. We are already in discussion with them, who is already using an RCA, and create this template, work with them, train the operators on the right sampling and testing procedures, and also document the concrete which is made out of this. So we have a good template, we have got a good document which will actually provide the necessary confidence building measures. So this is what we have in plan, and in the second part of the project. So this is where we are. So thank you so much for your attention, and thank you so much. Second part of it.
Can you please go to the front, first slide? Good evening to all of you. Thanks to Chairman and Co-Chairman for allowing me to speak on the challenges in implementation in large-scale projects. So I come from the contractor background. So what are the challenges we face? So probably many things have been explained before by various people, various speakers. So all of us are aware of SDGs, and large companies are looking at SDGs carefully along with ESG parameters. And the government also has an ambitious housing program. So if you look at this construction activity, there can be so many materials. So predominantly in India, concrete is a favored material of choice because you can make it into any shape you want, and for any type of concrete, SEC, roller compacting concrete, be it a dam or a building or an airport, you can make it. And the aggregates are always in huge demand because approximately 3/4 of the concrete content is made of aggregates. So they form the backbone of concrete. So if you look at the natural aggregate characteristics, the qualifying parameters are chiefly grading, crushing, impact, and abrasion value, and among others, there are so many other things. So in this discussion, we'll just confine to these parameters. So if you look at a natural aggregate source, the quarry is well defined. So what is the type of rock strata? Is it basalt, granite, or laterite, as someone was saying in the morning? And then you are having a well-defined process. If you look at a VSI 3-stage crushing process, is a primary jaw crusher, and then a cone, and then a tertiary impact. So you get the sand and aggregates of the desired parameters you want. So it's well defined. But if you look at C&D waste, people always think that because it is the waste is the word is there, it is a second-rate material. It is not the case, as I will explain later, because we are seeing piling up of the C&D waste due to natural reasons, natural disasters, and if there is a legacy infrastructure, you need to dismantle the infrastructure and build new infrastructure in its place. So it is generated in various forms. So as the Secretary mohua pointed out in the morning, so instead of ending up in a landfill, we need to use it in a productive manner. So even from nuclear power stations, so for example, in the UK, they have started using the C&D waste for new construction. And India is also having an ambitious circular economy, Agenda 2030. So recycled aggregates, if you just look at recycled aggregate on the whole, it can be a mixture of so many material in it. So this is from the UK MPA Mineral Products Association I taken. But if I am concentrating mainly on recycled concrete aggregates in this presentation, where we are processing the concrete debris generated from so many projects, and then by a well-defined process of crushing, screening, and washing, we are able to get the aggregates, both coarse and fine fractions. So in the project which my co-speaker, Mr. Shemendranath, explained before me, this is for a project in Navi Mumbai where we have built our own precast factory for Sitco Housing Package 4. So in that, what we did is we want an ambitious program. So we want to build the entire grade slab using recycled material. But in time, as Mr. Shemadnath pointed out, getting the debris and then processing it was a huge challenge. So, but what we did was, okay, we thought that we will do it anyway. But the one thing what everyone points out is the mortar sticking to the recycled aggregate because of the variable water absorption capacity. The quality of the concrete also could be variable if it is not processed properly. So Christian also showed in the morning that the mortar sticking, if you spray phenolphthalein solution, it will turn purple. But setting aside all those concerns, so there has been established studies in the UK elsewhere. So whatever metros we are building or big projects like the Ram Mandir, it's all for 1,000-year service life. All the metros are designed for 120 years plus year service life. They're all borrowed mainly from the highway agency in the UK, all the standards and the templates. So, but if you're using only pure OPC, for example, if you see the top row, which is having the RCA content, 0 to 60%, the service life is something around only 47 years. But if you are using fly ash, for example, 30% fly ash or 50% GGBS, so you're replacing the clinker content in your concrete, you can end up with a service life of 120 years. So even in high-speed rail, for example, it started only with OPC, but I think IIT Bombay has stepped in and then now you're using GGBS in the concretes. So in an aggressive chloride environment, for example, in Mumbai, for example, instead of using pure Portland cement, if you're using 100% recycled aggregate and 50% GGBS, it is supposed to outperform the Portland cement natural aggregates combination. So RC and GGBS is good for durability and sustainability as well, because with pure clinker content, you don't have the durability inbuilt into it. So why I am pointing out this slide is, currently we are also doing a lot of 3D printing works across India. So 3D printing is a great guzzler of OPC clinker, something around 500 kg per meter cube. And since coarse aggregate is not used, lot of sand is used, something around 1,500 kg per meter cube. So if you are using recycled sand and then GGBS also in it, so your 3D printer structure also could be made with less embodied carbon, and at the same time it could be durable as well. So I'm just going back to the UK standards BS 8500. So use of RCA was allowed as early as in 2002. So there is a country that has used quite a lot of this RCA material for more than 20 years and no concerns have been seen. Suppose if the source is known, so you are breaking some precast units where the quality is high, not only because of the higher grade of concrete, because it is in a controlled environment, and if you break that precast debris and recycle the material, then you will ultimately the quality of the concrete also will be good. So in India, we have made some beginning. In 2016, BIS has included this provision chiefly to Mr. Jose Kurian. But there is some limit, up to 20% or something. Again, we want to break that limit. So we engaged Center for Vetting and Approval, and Mr. Shemadnath was closely involved in this process. So first step, we replaced the fine aggregate by 50% RCA, and there was no pressure from any agency to get any brownie points. We did this on our own. So this is an example of the grade slab. So we wanted to do the entire grade slab, but by the time we got the debris, probably some 60 or 70% of the grade slab was already constructed. So these are the debris from a metro site, and this is how the proper processing of the debris was done in a recycling plant. And what we did was, with the M10 grade, we actually went up to 100% recycled aggregate sand, and with M20 we did with 50% RCA sand. So it all exceeds the limits given in the IS 383, and is also well documented in the ICJ paper, which Dr. Christian showed earlier in his presentation. So even the Royal Norwegian Embassy official visited the factory, because this factory is more than 2 years old, and the grade slab has witnessed a lot of vehicle movements, heavy movement of trucks and other machinery. So it is in completely perfect shape, and if anyone is wants to visit this factory and see how the grade slab is performing, you are welcome. And we also got an appreciation from Sintef. So when it comes to challenges, what are the challenges? Across India, we don't have the availability of this material. Probably in Delhi, you are having plenty of vendors or various arrangements to get the material. So getting consistent quality and for timely completion, because we all do large projects, our requirement is also huge. And the availability of debris and the grade of debris is also an important thing. And there should be a good vendor system, that is ecosystem should also develop. And probably clients also should encourage approving the concrete mix designs made with recycled concrete aggregates. So the other thing is, whenever there is a reconstruction, for example, this is a Hyderabad airport. If you look at the apron concrete made with M40, the concrete has been broken. It almost looks like a rock. But unfortunately, we did not get the permission to put an on-site recycling plant. So it was sold to some other vendors for processing. So these are some of the concerns I wish to express. And thank you for your kind attention. Thank you all.
We'll now invite the last presentation, which is Mr. Abhijit Gaude and Marianne. They will be presenting about the global warming potential for concrete blocks, which are developed using C&D waste. Please.
Yes, thank you for the kind introduction. As has been previously mentioned today, Syntef and Godrej have been working together to help document the environmental qualities of these recycled concrete blocks. And that is what we're going to talk about and present today. So our main goal in doing this life cycle assessment, LCA, is in order to be able to create this documentation, Environmental Product Declaration, EPD. And this is a short document that summarizes all of the environmental indicators, all of the impacts and benefits relating to the recycled concrete solid blocks and paver blocks. And what is really special about this is that Godrej is going to be one of the first to publish EPDs for RC blocks in India. So there's many aspects with life cycle assessment, and it can be used as a tool as well to improve the environmental performance of different products and services. So this is also something we've been looking into by seeing how we can decrease global warming potential for the recycled concrete solid blocks through the use of C&D waste in production. But we can also save emissions from using green energy in the manufacturing process. We've heard the presentations earlier today about the carbon emissions that can be saved through carbonation of concrete. And then also we have this increasing the fly ash content as well as another parameter that can be explored. So when it comes to life cycle assessment, we've followed these international and European standards for the life cycle assessment. The first one, ISO 1404044, is the kind of overarching method of life cycle assessment. And you always start by scoping out what the goal of the assessment is. What is it you want to achieve by doing this environmental documentation? We then have these two European standards. EN 15804 is the methodology that's used to create EPDs. They have some very strict requirements about how you're meant to go about creating this documentation so that it is comparable between different manufacturers. And then we have EN 16757, which gives a method for measuring the carbonation of concrete and how that is then to be incorporated into the EPDs. Some guidance there. So when it comes to LCA and EPDs, we have a lovely system of letters that breaks down the whole value chain from the A phase, which is your production and construction. We have the B phase, which is the use phase. The C phase is end of life. And then we have this bit of a strange life cycle module D at the end, which is actually outside of the typical system boundary and explores the loads and benefits outside the system boundary. So that module can be used to compare recycled concrete blocks with regular blocks and see what the environmental savings are. So I was just going to quickly explain what the different codings mean there, and it's something I'm going to keep coming back to within the presentation. So A1 is the material extraction, whether that be raw materials or the recycling of the materials that are then transported in A2 to the factory. A3 is then the manufacturing process. And then A4, you have the transport from the plant to your construction site. B1 is where we document the carbonation of concrete. C1 is then the demolition. C2 is the transport of that demolition waste to the recycling facility in C3. And here I haven't got a logo for C4 because that's actually landfill. And we don't want the construction and demolition waste to be sent to landfill. We'd rather go full circle in the circular economy and feed it back into A1. So I hope you're all with me so far. So then the first step in doing a life cycle assessment is that we need to map out all of the inputs and outputs within the system model. So we're looking at all of the materials, energy, water that's going into that product system, and then measuring what is coming out the other side in terms of waste emissions and maybe also byproducts. And what is special with Godrej is that they're using the construction and demolition waste as an input in the materials. They have a green certificate for the energy use, so they're also using rainwater harvesting so that you're not depleting the natural water reserves. And then we've got this circular action going on with the outputs of waste is then fed back into the process model. And I mentioned this module D. So this is actually using consequential LCA instead of allocation method. And it's looking at what happens if we close that loop. So for example, if we're using 69 kilograms of construction and demolition waste into the production process, and we're getting 1 ton of product out, then we have a net output of 931 kilograms of substituted products. So then what would happen if we then did exactly the same life cycle assessment I showed previously, but without that construction and demolition waste? Then you have 2 sets of results and can compare what the savings are. And you subtract one from the other so that you then can have a calculation of what the environmental savings are for your product. So we first started by doing the LCA calculations for an average recycled concrete solid block and paver block. And then once we established that, we were able to do the same calculations for all the different product variations that Godrej have for their solid blocks and paver blocks. Once we've then established our life cycle inventory of all the different product variations, then we come to the next stage in the LCA, the life cycle impact assessment. And what I wanted to highlight here is that we're not just measuring global warming potential, the carbon footprint, but there's a whole host of different environmental indicators that are to be documented in an EPD. And I think especially for concrete products, one of the other major ones to think about is this one, PM, particulate matter. And so we can see what is the impacts of particulate matter from, for example, the manufacturing stage in terms of the dust production and also throughout the whole value chain. Another one that's quite useful to look at is FW. Where is it? There. And that's looking at the fresh water consumption throughout the entire value chain as well. So there's a lot of useful information that you can find within the EPD, but it takes a little decoding because there's a lot of acronyms. So I wanted to share with you some of our preliminary results for the Godrej recycled concrete blocks. And here we have the results for all the different environmental indicators. And I think one of the interesting finds here is that we have global warming at the start here, but the environmental indicator that actually has the most environmental impacts is ecotoxicity, followed by the resource use of fossils, land use, and non-renewable primary energy. And that is mainly from the use of diesel in the forklift and in the transport. And yes, also, yeah, from the transport and also the operations at the plants. The other thing is that not all environmental indicators are negative impacts. Towards the end, we have this environmental indicator called materials for recycling, and this is where we see that the 1 ton of product that comes out can go full circle again and be fed back into that material circularity and closed loop. So that one's actually a good result. Yes, I also wanted to go into more detail about the global warming potential impacts of the Godrej blocks. And it's probably no surprise that the majority of impacts are coming from that A1 raw material supply, which is coming from the cement content. And this is followed by the A3 emissions from manufacturing, which is around 10% of the total emissions, followed by transport. So this also can be used as a tool to identify, okay, where do we actually need to focus our efforts to reduce carbon footprints? And then if you remember what I said about Module D, we can see what is the savings of using recycled content versus your traditional bricks. And it's around 9% in this case, based on the amount of recycled concrete they're using. But again, you can play with the amount of inputs and outputs and perhaps even increase that if it's preferable. I also just wanted to show this, it's the same results, but in a visual network, and it's just re-emphasizing where the majority of the emissions are coming from. So the thickness of the arrows is the largest inputs. So again, it is from the cement input from the A1 life cycle module. And at the start, I mentioned about doing the sensitivity analysis and playing with the different dynamics. And we also looked at what would happen if Godrej increased the fly ash content of their blocks to 35%. And we see that it's possible for them to save 11% of total global warming potential emissions by doing that. So, in summary, what does this all mean? From the study we've done so far, we've found that the majority of global warming potential emissions are arising from cement, and that we can save around 9% of these total greenhouse gas emissions by using C&D waste. We also see that using green energy in the manufacturing of the blocks is a potential for saving emissions, as well as the carbonation of concrete. I didn't include that in this presentation, but the plan is to include it when the EPDs are published. Again, we can save a further 11% of emissions by increasing the fly ash content. And I think it's very easy to get focused on carbon emissions and get this kind of tunnel vision of just, we've got to do everything we can to cut emissions. But it's also important to consider other environmental factors as well, like particulate matter and especially air quality. Also ionizing radiation potential, resource use of fossils, ecotoxicity, and there's some materials for recycling. And yes, you've seen this image a few times today, but we're very close to finalizing the LCA report and EPDs, ready to be sent to this third-party verification. And this is also a very important step when producing EPDs, to make sure that we're all following the same method and that the results are correct, they're verified by a third party so that those that are reading the EPDs can trust the results. And I think the next steps, we're going to be looking into some of these other measures of how we can optimize the value chain and reduce emissions in the whole life cycle for the recycled concrete blocks. Thank you.
Thank you, Marianne. So, in coordination with CENTRIP and you all seen this global warming potential and then the environmental impact indicators already we have taken into, because we already in the post assessment in Greenco CII Greenco assessment we have taken into the positive consideration. So in ecotoxicity we already the using the recycled water as well as the groundwater we minimize because of the potential rainwater harvesting capacity structures are already placed in this. And regular studies shows that to reduce the scope 1, scope 2 and scope 3 emissions, we have the synergy mates with our suppliers and vendors and also our business partners. We are continuously auditing with selected parameters and also giving because already Goran and boys have the mission sustainable growth. We have the set targets about energy reduction, water reduction, and also carbon intensity. So those targets we have taken, those targets also we are our partners were communicating, these are our targets, you are valuable partners with us, supplier with us, you also take environmental indicators, you have to minimize your supply chain. So these are the focused area. So already doing a lot of environmental indicators where the best technology in our process will continue that. Thank you.
Thank you, Dr. Shivana Gowda and Marianne, for sharing details of your work. We have had 4 very interesting and insightful presentations. Before we close the session, we have about 10 minutes, and a lot of information has been shared. We would like to take an opportunity to have at least one round of questions. So if anyone has a question or a comment that you would like to share with us, have our speakers respond, please come forward, raise your hand, let us know your name and the question you would like to ask. The floor is open. Please, please.
Sir, why this restriction of usage of 20% of RCA continues even after 10 years of so much of work being done on CNA in India and abroad? Why this restriction continues?
I think that's a good point. Maybe, yes, you would like to respond, and after that, Dr. Christian may want to add to that. Please. Is there a mic which we can move around in the hall? Do we have a mobile mic somewhere here? Yeah, it's there.
Interesting question. As per the restriction, sir, we give our example. For example, we have supplied our Mumbai coastal road projects, U-drain and box culvert, the more than 435 units. There we increase the percentage of the recycled concrete. And also, we can increase as per the demand and your the quality testing, and also taking care of the all environmental parameters. So as per the restrictions of the policy, again we need to stressful things. We need to hammer on to the government policy. We need to change this. This is the concern. Yeah, I agree, sir.
Yes,
That's what I'm coming to the
conclusion. To add. Thank you, Dr. Shivana Gowda, if we can add to this.
Hello? Yeah. Of course, we can, we have emphasized on either increasing the percentage to 30% or even 40%, because we see good results from other parts of India, but also in Europe and in Norway. Or we can, we also emphasize that it's needed to go up beyond M25, maybe M30 or M35 to have a bigger market. Having said that, then it's very important to realize that you cannot put 30% of unauthorized RCA into RCC. That's I don't think that will happen. It will be stopped, or the bottleneck is too high. So that is why Shemendra and we have focused on the BIS is there, but it's not BIS role to specify a quality manual for the different recycled operators. That's why we are now working on a technical specification on how you are arriving to compliance to 383. So if you have certified to be in compliance with 383, then you can then it's more acceptable for CPWD or other construction agencies to use accept concrete with RCA of 20%. And if that milestone has been reached, it's very easy to increase the replacement level to 30 or even 35%. But but the backbone must be certification and testing. Otherwise, it's too risky.
I just wanted to add one more point to this, because I had also talked to Mr. Jose Kurian, who's the chairman of the CED, Cement and Concrete Subdivision. So what he says is that, see, you may be able to control what you do with yourself, with you people taking right. But when we make a code, we make for the code for the whole country. So we need to make very sure that whatever we recommend today is not being misused or abused. And for that, we need documentation. We need to have this testing regime in place. So we need to put all those things in together, which will give them the confidence. That's exactly what we are working on.
Thank you. We have been advised, yes, we will take more questions. We have been advised that, having a panel discussion at this point may be interesting. So we would like to invite a few more people to join us on the dais, and then we will be able to collectively take more questions. So may I request Shri Bibi Makkar Saab, who's kindly here, to please join us here, sir. Dr. Christian, if you can also join us, and Shamendra, if you can join us. Then we have a panel discussion which also helps us in, kind of wrapping up, because
So before we proceed further, I would like to invite Mr. Prem Mohan, Chief Engineer CSQ, to please felicitate Makkar Saab.
Thank you. So we had a question that side. Please identify yourself, and if you are directing question to one of us or even others, feel free. Thank you.
Good afternoon, sir. My name is Shravanti. I am Assistant Advisor from CPHEO. My question is to the panel members. When we talk about use of recycled products, so there will be some quantum of virgin material that will be going into making these products. So I would like to get a thumb rule sort of what is the quantum of virgin material that goes into making these recycled products. And the second question is, what is the cost involved, like compared to the conventional products that are made? Are these products like 1x times expensive or 0.5 times cheaper? So we would like to get a broad figure, because there is a lot of talking about the perception of public when they use it, or perception of contractors when they use it. So I would like to know these details.
So Christian, you want to start a little bit about it, or Makkar Saab, would you like to respond? Please.
Actually, I used a lot of C&D waste blocks in Supreme Court construction. So about 18 lakhs block we used there. So at that time there was no code, and there was no technology available also, except few plants were there. So when we got first sample, first lot of blocks at our site, so those are very poor, means the strength was very less, and it was not usable. They were not usable. So we initially targeted a strength of 10 MPa. So at that time we were reaching about 5-6 MPa, so it was not for us. And there was a contract between contractor and the producer, block producer. So then we went to lab, and we again mixed the design. So we added some more cement in that. So we made it to M10, MP10. So for your answer, we have to add cement as binder in that case also. Otherwise we won't get that required strength. Other material is recyclable, but except virgin material is cement, we are going to add. The second question is about the price. So we worked out price also. So it is almost same with the fresh virgin block or CC block, or this recycled block, means C&D waste block. But indirect saving is lot more. By using 18 lakh concrete block, we saved about 25,000 ton of good soil. which is used in making bricks. So there are so many indirect benefits. So if we are getting equal price, then we should move for C&D blocks. Thank you.
Thank you. Do you want to add, Doctor, anything on this? Because you are doing fair amount of recycling internally. Any reflections on the cost side you would want to share from Godrej perspective?
Some of the innovative projects already we are with some IITs like Twasta, like we recently built using in recycled concrete road. There we are increasing, and also one of the pioneer project in a cocoon project that's very innovative with less than 48 hours. We have implemented at our Kalapur project site, that is office building, and also the innovative projects like security kind of cabin stuffs and all. We are increasing up to 30 to 40% recycled concrete aggregates and all.
Thank you. If I may, yes, Shavindra, please.
So I just wanted to add something more to what you asked. It's a very relevant question because it's very pertinent as well. Because if you want to use recycled aggregates, you need to know what is the impact, economic impact also. So when we did this business plan in Goa, we looked at the aggregate, the virgin aggregate price, and we took 10% off on the selling price of RCA, and still we were good enough to make it a standalone business case with the modeling. We haven't done exactly the complete physical financial breakdown of that, but it is still possible to sell at 10% and make a good decent profit. That's my take on the current, but then all these are very relative. The moment a carbon tax comes into play, then suddenly your prices will be more than better. It looks much better than that because you need to factor in the environmental impact that this makes it. So a lot of things make it very challenging and exciting as well.
If I may just add, so on apples to apples comparison, because many times the comparison is not apples to apples. So I'm emphasizing, when you do that, you will find the price of recycled materials to be significantly lower. Significantly lower. It of course varies from one city to another because of the transportation element, which is difficult to say. But many times what happens is the comparison itself is not apples to apples. So if you heard the presentation I made in the morning, many times the natural aggregates or natural sand is mined illegally. When it is mined illegally, it is of course naturally supplied illegally. That means payments are in cash, that means the labor has not been paid a fair wage, and so many other things associated with it. On the other hand, when you have a recycling facility, which is a formal facility, everything is above the board, and you pay based on a GST applied invoice, then your comparison is not apples to apples. And therefore, if you do that, you will find there is hardly any place in India where recycled materials will not be cheaper than natural aggregates.
Just one comment to that, Gaurav.
Please.
Yeah.
Yes.
In Norway, we are trying to not go so much decrease in the price of recycled product, because you can ask why should you why should it be cheaper? It shouldn't be cheaper. And one of the key to have the market acceptance that you are on a 95% or 1-to-1 price is actually big construction projects or tenders for big construction projects are weighting the environmental factor more, up to 33%. And then the bidders need to take this into consideration, and that creates a much better market for the recycled products. And there are a lot of benefits, and we have heard them from Marianne about what are the indicators if you do a full LCA. It's not only the CO2, it's a lot of other indicators and parameters that are playing into this game. So the development for the demand for such type of documentation is also very, very important factor.
Other questions? Yes, sir, please.
The question is that we were talking of the mini plants which can be installed at the site itself. So what is the break-even point requirement of the availability of the material where these are viable? Thank you.
We have someone from CDE. Sanjay ji, will you want to comment a little bit, because you have been supplying various technologies, what could be a break-even point in terms of volume of material? I think that's what he is asking. I did a calculation which I presented, which I felt was about 100 tons per day, which may be perhaps viable, but you know better, Sanjay ji, please.
2-3 points I would like to share. One thing is that which one my personal belief, just I will share. First thing is that there is no option which one is cheaper or which one is economical. Material is not there, then we have to recycle it, even if it is costlier. That we should make it in mind. Material is not there. So many presentation we have seen, there is no aggregate available on this earth, on this planet. Sand is not available. So even if it is costlier, we have to buy Bisleri and drink, because clean water is not available freely. This is one thing. Second thing, as per the 2016 rule that has been made mandatory, every corporation and municipality should have minimum one such existing operative plant. Unfortunately, so far it has not happened. Again, I will say, again, there is no cost analysis involved. We are playing with our children's lives, so many diseases, particulate matter. So necessarily it has to be done. Whatever the extra margins are required to be given, that is coming from the corporation as a tipping fee. So moderately we understand, we have supplied almost 24 plants running all around the country. 100 tons means something like 1 truck per hour. 100 tons plant is feasible. That requires 6, 7, 8 crores rupees investment. And depending on the tipping fee and operative and quality you get a prime project, prime material, aggregates and both. Market is accepting, especially the technological companies are accepting. Maybe ordinary people may think that this is recycled, but technological engineering people, they know that this is better material in most of the cases, like RA. Recycled aggregate is sometimes better than the virgin material because it is properly cleaned, segregated, graded, and all the unwanted materials removed. So, any other thing? Could I make your point clear, sir? Yeah, tell me, sir. Our plant footprint is very, very small. It is roughly around 30 meter by 20 meter.
30 meter.
Yeah, but you need to have some 1 acre, 2 acre plot so that you can keep your debris from some stock, some outputs, vehicular movement, etc. Our plant footprint is minimal. Plant footprint per ton of power consumption, per ton water consumption, per ton manpower consumption, that is the world record, that is minimum. Our plants are running Delhi, Bombay, London, New York, everywhere.
Approximate cost of installation?
It will cost around 4 to 5 years.
Okay, thank you.
Yeah.
Thank you, Sanjay. I will also, this is an interesting point. Sir, you're talking about same point or a different point?
Yes, sir. See, because I have doubt when I discuss with you, if we will mix the synthetic with concrete, that will act as a foreign material. How you will address this?
Sir, can you please elaborate your question?
My question is disposal of the sport surface, that is synthetic track. If you use, what is the methodology to recycle the synthetic track?
It's a slightly different subject. We will come back to that, but before we close on the question which was asked, I would like to invite, we have, two operators here. One is Ever Enviro, and second is, what's the second? Rise 11. We have two companies who have experience of operating C&D facilities. I will invite Manoj ji and Sandeep, if you can also briefly share your experience on operating the facilities. How much does it cost you, particularly for a smaller plant? You have also been operating a smaller plant. Sandeep has been operating larger plants. But if you can talk about that for the benefit of our friends here.
Thank you. Sir, we are operating a 150-ton per day capacity plant and also a 300-ton per day capacity plant. So as a question was about 100 ton, or what will be the minimum size of plant which will be economically viable. See, there are a couple of parameters in that. One is like the initial capital cost. So initial capital cost for anything say around 150 to 300 ton per day capacity plant, in like as per our experience will be in the tune of around 12 to 15 crores. So that is the capital investment. Now, much more important is your source of revenue. So that depends a lot upon the quality of waste and the quantity of waste you are having or you are receiving. We are currently operating for municipal corporations at 3 different locations. So it depends a lot upon like the other projects which are operating in that city and how much waste is actually genuinely coming to the recycling facility. That is a big question mark at present, which even our member secretary at the beginning of the today's session, it was appreciable on his part that he acknowledged that waste is not coming to the recycling facility. It is being dumped. And that too after almost like 6-7 years of having the construction and demolition waste rules established in 2016. So one is the capital cost, secondly is the operating cost. Operating cost of 150 ton or up to 300 ton per day capacity plant will also be substantial. That will be in the range of around 300 to 400 rupees per metric ton. So your major source of revenue will be by selling of the products, recycled products or the value-added products made out of that.
Thank you, Manoj ji. I think from a CPWD perspective, you are perhaps looking at even smaller plants. These are city-level plants which you don't need that big size. So the capex, of course, comes down.
No, my question was from the point of view of a larger project, say in a 500 crore project for the redevelopment of our works, if we want to install a micro plant, so that whatsoever,
yes,
on the site itself, so that whatsoever the waste is being generated there, we must recycle it and reuse it.
Yes.
For that angle, it was my question. It was not for the municipal or the earning the revenue. That was not the objective.
True.
Thank you.
No, thank you. That's why, what Sanjay ji said earlier about 5 crore roughly ballpark investment is what you may need with a relatively small land footprint. And in fact, the plant which Sanjay talked about are kind of plants which you can pack up fairly quickly. Maybe in 1 week it can be moved to one location to another location. So if you have, like in Delhi, you had multiple redevelopment projects happening one after another. You could, do it at one site, let's say for 6 to 12 months, move it to the next site and move it to the third site. So over a period of 5 years, you have used it in 5 different projects. I wanted to also draw a little bit, Dr. Sevakumar, you talked about your project in Mumbai, CIDCO project.
L&T being one of the progressive companies, so what are the plans, how are you thinking of scaling up, your focus on absorbing more and more recycled materials?
So when it comes to L&T, it is mostly we are tied up with the technical specification which is framed at the very beginning of the project. So most of the decisions on using recycled materials has to be done upstream. So maybe the structural engineer, architect, or whoever does the planning part, they need to include in the technical specification. So notwithstanding that, for our own facilities, we are now looking at reducing the clinker content, and also we are looking at using the recycled materials. Unfortunately, good quality recycled material, as we have done in this Navi Mumbai project, we are not able to get in other cities. But having said that, we are also looking at new contract documents, which are also not looking at only the concrete strength, but also they're specifying what is the embodied carbon that should be there. So already the limits are coming in terms of embodied carbon. So in one of the projects, we are also framing our mixed designs accordingly. So it is more driven from the external ecosystem for the larger public projects.
So Makkar sir, how can CPWD include it in your tender documents, more and more projects, to have these requirements built in? Because our friends in the private sector industry, they look upon the requirements. Actually, to set up a mini plant, we require, first of all, we have to decide what we are going to produce. Are we going to produce all the output products like paver blocks, drain covers and all those things, or are we just deciding to produce RA and RCA? Second, what will be our input? Means what will be the generated waste, quantum of generated waste. And third important point is space available, because in major cities scarcity of space is there. So I don't think we can sustain a plant at site. I think his point is more about the requirement of using recycled materials at site. No, not necessarily. No, his point was he want to have a mini plant at construction site itself. That was his question. Is that your question, Dr. Sivakumar? No. Achha. No, I was answering his question. Can you repeat your question? His point, sir, was that L&T and other contractors. When I said that why are you not expanding your project like what you did at the Sidco? They had a whole grade slab. So his point is that they can use more recycled materials only if the tenders and the designs which major developers are asking them to do. And CPWD being one of the largest developer, I'm wondering what can you do to include it in your requirement, so that when the bid comes out, all contractors have to comply to this your requirement. In effect, you are developing the ecosystem and the market for recycle. Because Shamendra wants to add to this.
I just wanted to add, Shiva, probably with L&T in Kudangulam nuclear power project. So I had one Raghupati giving me this information about the kind of recycling what they have done. They said that they have done around 1,600 cubic meters of recycled concrete there in Kudangulam. And they have crushed around 10,000 metric tons of concrete waste and the demolition waste. And they have utilized that. So at the site level where permitted, it has been used, and it's a huge number what we are talking about. So there are things happening. Probably we need to collate and keep all this together to have a better understanding about what's really happening in the country.
So in Kodangulam, being a big massive project, the waste was generated, but it won't happen in other projects where the concrete waste is less than 1% of the total production.
No, have you seen Mr. Bhagat Singh's presentation? He told we are in CPWD, we are using 1 lakh ton of R&D, this C&D waste in this financial year, I think. About 1 lakh of ton we have already used, and another 10,000 to be used by the year end. And in most of our agreements, we are stipulating 10 to 20% of usage of C&D waste. So it's not like we are pioneer in this field, and we are proceeding with that only.
Sure. I think it's important to define in a redevelopment project what you are going to use or what your goals are with the recycled products or the recycled aggregates. Because if you look worldwide and also in India, if you're going up and using RCA, it is I have at least not seen it. You don't have a certified process of using RCA at site. That belongs to the stationary phase. If you go to the very front runner in Europe, the Netherlands, there are no certified processes at site for RCC. I mean concrete with reinforcement of steel. So then you have to use the new technology in Norway and change to aluminum reinforcement, but that is another chapter.
Thank you. Any other comments, questions? Please.
If there's any work or research done on the use of process inert in the waste management plants. See now, for 100 tons, it is minimum 10% which will go in the landfill. Now we achieved 3% in Goa, but it consists a lot of things like sand. So many things are there in that, depending on your lifestyle, your food habits. Is there anything for the use of this? Because 3 tons for 100 tons per day is a huge amount.
That
cumulatively, you see, is there any use of this? Just like in making some products.
This is, I think, I have the recycling, Mr. Sandeep and Mr. Manoj also with me. That is a challenge, of course. You have to get offtake of the fines, and up to now there is, at least to my best knowledge, there is no complete solution out of it. But we are looking, there are no big initiatives on it, especially in activation, try to compose a geopolymer system out of it. And that, I think that is the state of the art right now, but it is very much indeed the focus, because if that is solved, then it solves a lot of challenges for the mobile plants as well. I mean, it's not only to put up a small mobile plant in a redevelopment project. You need to have offtake of the fines as well. Okay, you can use the sand and the coarse fraction, but what do you do with the fines? So it's you bring up a very valid challenge actually. So
Christian, the contamination of the heavy metals or something hazardous material in that is another challenge. Like we get batteries, everything gets into that. But it's a huge challenge because landfills are not just available for land is not available for the length of that particular license.
I think as per now, it's the low-hanging fruit is either blending some kind of activation or use it as a filler. If you can utilize it as a packing effect. I have seen production on Shastri Park where you get quite good strengths out of it, and that is a good packing effect. In addition to the fact that you may have some unhydrated cement grains that are adding up adding to the strength. So I think whether if you go to these plants available or running now, it's if you do filter press or if you do easy settlement or easy rapid sedimentation, there is distinct routes. If you do the filter press, we struggle a little bit with this in Norway and trying to find. Of course, you reduce the volume, you reduce the water, and you can transport it, but it is very much difficult to disperg it again, for example, as a filler into concrete, because you need the mixing system. But if that was solved, you could actually have some offtake of it, because you need I mean aggregates which is low in the fine area in your grading curve, of course this goes directly in there, no problem.
We are coming towards the close of the session, so one last opportunity for anyone before we close the session. Synthetic waste, if someone will like to address, is it's a, you know, I think it's a combination of a rubber and plastic, perhaps. It's a rubber. If you know the racing track on a athletic stadium, you know, so they have recycled that from one of the stadiums and they are wondering what to do with it. It's not a traditional C&D waste. It's more of a rubber, and my initial reflection was maybe to think about, you know, co-processing maybe in a cement kiln because it's a high calorific value material, but I don't know if there is possibility to do that or any pilots around that has been done. But, you know, if anyone has any thoughts on that.
I personally have I don't know about any projects that are using it as aggregates in concrete, or my first thought was rather to asphalt production, but again I don't have any experience with it.
So it's been a very interesting conversation and insightful presentations. I think at this point I will hand it back to CPWD team to close the session, but I take this opportunity to thank all the speakers and my co-chair Makkar Saab and Ram Dayal ji. Thank you so much. It's been a really wonderful session. Please.
Thank you, sirs. Shri B.B. Makkar sir, if you don't mind, can I please call upon all the speakers, and if you could kindly felicitate them. To begin with, could I kindly have Mr. Shomendra Nath P. on the stage, please? Oh, there he is. May I have Dr. Shivakumara on stage, please? Could I request Dr. Shivana Gowda on stage? Thank you, sir. And Ms. Marianne R.K. Wick, please. Thank you, sir. As they say, all good things must come to an end for a promised beginning. With that thought, I invite Shri V.P. Sahu, sir, to please come up and say a few words as a way forward and thanksgiving. Thank you.
Thank you very much. Esteemed guests, speakers, senior officers of CPWD, colleagues, ladies and gentlemen, as we conclude this enriching workshop, I stand before you today to express our collective gratitude to the distinguished individuals who illuminated our shared journey into the realm of construction and demolition waste management. Their insights and experiences have cast a beacon of knowledge that will guide us in our future endeavors. I express my profound gratitude to Shri Rajesh Kaushal, DG CPWD, for the C&D waste initiatives being taken by CPWD. Without his untiring guidance, it would not have been possible for us to organize this workshop. At the forefront, we acknowledge the contribution of Shri Bharat Sharma, Member Secretary of the CPCB. His expertise painted a clear picture of the current landscape within the C&D Waste Management Rules 2016, equipping us with the knowledge to navigate this crucial territory. Your guidance serves as the foundation for the informed action. Our deepest gratitude extends to Dr. Levinson Martins, Managing Director of the Goa Waste Management Corporation. Drawing upon his first-hand experience in Goa's pioneering C&D waste recycling initiatives, he offered invaluable practical perspectives that inspire us to replicate his remarkable success. And his invitation to visit Goa is also highly appreciated. We commend Shri P. Bhagat Singh, Chief Engineer CPWD, whose insightful presentation shed light on the adoption of C&D waste products within our esteemed parent organization, the CPWD. Commitment to internal circularity of C&D waste sets a precedent for wider implementation in the future, paving the way for a more sustainable future. A heartfelt thanks to Dr. Gaurav, Director of RTI International India, by discussing the economic models tailored to sustainable C&D waste recycling. You bridge the gap between intention and action, transforming aspirations into tangible possibilities. Your economic insights are the bridge to a greener tomorrow. We commend Mr. Shemendranath Pandey from Resilient Solutions and Dr. K. Shivakumar from L&T Construction for their candor in highlighting the challenges of integrating recycled materials into large-scale projects. Your transparency ensures we approach implementation with realistic awareness, setting the stage for successful and sustainable solutions. A special shout out goes to Dr. Shivana Gowda from Godrej and Miss Marian from Sintef. Through your groundbreaking research on the impactful reduction in concrete block global warming potential through C&D waste integration, you illuminate a path towards a more sustainable future. Our deepest gratitude extends to Dr. Christian from Sintef, our esteemed partner in this event, a distinguished speaker on the advancements in the field. Your expertise and collaboration are invaluable, and we look forward to continuing this insightful partnership. Furthermore, it is my privilege to acknowledge the dedication of the chairman and co-chairman of both technical sessions, Shri S.P. Chaudhary, SDG CPWD, Shri Rajesh Manga, Chief Engineer CPWD, Dr. Gaurav, Shri Ramdayal, Chief Engineer CPWD. Your leadership steered the sessions with exceptional acumen, ensuring knowledge flowed freely and productively. A special thank you goes to Chairman Shri B.B. Makkar, retired SDG, for joining the concluding session alongside Dr. Christian, Dr. Shemendra. Your guidance brought the event to a successful close. Our sincere appreciation goes to Shri Naimuddin, ADG Tech, Shri Prem Mohan, Chief Engineer, CSQ Civil, for their dedicated leadership. We also extend special mention and appreciation to the CSQ task team headed by Shri Dinesh Ujjainia, whose efforts and guidance were instrumental throughout the entire process. We are immensely grateful to the organizing teams from Sintef, CSQ CPWD, and Vigyan Bhawan CPWD, who meticulously orchestrated every detail, ensuring this event's resounding success. Shri Manish, SC Vigyan Bhawan, Shri Devendra, Sachan, Director Tech and PR, who are always available with a smile. There are many CPWD officers who played an integral role in the organization and contributed to the event's success, but remain unnamed. Their dedication is appreciated. Finally, our deepest appreciation goes to all the participants, both physically present and online. Your active engagement and insightful contributions are true hallmark of this successful workshop. The knowledge and connections fostered here will undoubtedly pave the way for a future where sustainable C&D waste management becomes a reality. Thank you very much.
Thank you, sir. Thank you, sirs. I want to express my heartfelt gratitude to each and every one of you for your active participation, thoughtful contributions, and unwavering enthusiasm throughout our time together. Your engagement has been the driving source behind the success of this program. You all are cordially invited for tea at Atrium ground floor with cookies. Please do join us. Thank you once again for your presence and participation. It's been an honor and privilege